frontiers in science and technology, serving as the nodal agency to organize, coordinate, and foster S&T activities across the nation. Science and vision hand in hand. Build a future bold and grand. 55 years, a journey of light, from humble sparks to soaring heights.
Today, we celebrate over 5 decades of unwavering pursuit of scientific excellence, innovation, and nation building. We are honored by the presence of eminent scientists, thought leaders, policymakers, and distinguished guests who inspire us with their vision and achievements. This auspicious event will be graced by Honorable Minister of State, Independent Charge for Science and Technology and Earth Sciences, Minister of State for Ministry of Personnel, Public Grievances and Pensions, Dr. Jitendra Singh, who also holds important portfolios in the Prime Minister's Office, Department of Space and Department of Atomic Energy. The inaugural ceremony of this 55th Foundation Day will take place at 11:30 a.m. today. We are also privileged to have eminent scientists from DST Autonomous Institution with us, specializing in medical technology. Please join me in welcoming Dr. Sanjay Bihari, Director, Sri Chitra Tirunal Institute of Medical Sciences and Technology, Trivandrum. Dr. Bihari will deliver the academic lecture slated for today and will enrich us with his knowledge, experiences, and success stories.
I request all the participants to please keep their mobile phones on silent mode. And also those who are standing outside are requested to assemble in the auditorium and be seated before we proceed further. I now invite Ms. A. Dhanlakshmi, Joint Secretary, Administration, DST, to deliver the welcome address and introduce the speaker of the day to the participants.
Good morning, everybody. Respected Secretary, Department of Science and Technology, Professor Abhay Karandikarji, CEO, ANRF, Kalyan Ramanji, and the Speaker of the Day, Sanjay Bihari ji, our AS and FA Additional Secretary, Sunil Kumar ji, and CCA, and my dear HODs from all the autonomous institutions, scientists and friends from all other scientific ministries like DST, DBT, CSIR, DSIR, and Ministry of Earth Sciences. First of all, I would wish you all on the 55th Foundation Day of Department of Science and Technology. From 1971, DST has proceeded a lot. It has developed leaps and bounds in its achievements. The recent achievement to our credit is the National Geospatial Policy being launched, the RDI venture capital being conceptualized and inaugurated, and our ANRF. These are some of the major achievements of DST in the recent times. And the Department of Science and Technology has revolutionized the startup ecosystem in the entire country. And the beneficiaries of the schemes of DST are not only within India, now it has extended to the entire world. With these few words, I have a great pleasure in introducing the speaker of the day, Dr. Sanjay Bihari ji. He has such great achievements which runs into pages and pages. And I am humbled by the educational qualification and achievements he has made. I am in fact fortunate to introduce him to you. Professor and Dr. Sanjay Bihari ji is MBBS, MS General Surgery, MCH in Neurosurgery, DNB in Neurosurgery, FRCS ad hominem, Edinburgh, FRCS Glasgow, FACS, IFAANS, IFAS, and FNA, FAMS, Vigya. He was recently awarded Vigyan Shri for medicine in the year 1924. Presently, we are lucky that he is Director, Sri Chaitanya Trinal Institute for Medical Sciences and Technology, Trivandrum. He was former head of Department Neurosurgery, Sanjay Gandhi Postgraduate Institute of Medical Sciences. He is an editor of 16 books, 4 bestsellers with theme publication, including 1 neuro-oncology atlas and 3 textbook of neurosurgery, and 142 chapters in book, 376 indexed publications, 729 citations, high index 45, I-10 index 185, guided 108 MCH neurosurgery, and 23 neurological senior residents, co-guided 6 PhDs and 7 MD students, performed 7,300 neurosurgical procedures, examiner for 26 Indian universities, country examiner for Sudan and South Africa. Sir, making one child prepare for an MBBS exam is such an uphill task for people like us, and you have successfully completed so many degrees. I would rather appreciate your mother's contribution in this. Thank you, sir, for being with us. Granted 2 patents, President-elect Cerebrovascular Society of India, former President UK Neuroscience Society, editor Neurology India, reviewer of 30 journals during 6-year tenure as chief editor of Neurology India. Its Thomas Router impact factor reached 2.716, highest ever in 65 years, and among one of the highest among international neurological journalists. Founder editor of Current Problems in Neurosurgery, CPIN, Journal of Neurology, supplement and video section of Neurology India. He has delivered 21 national orations, honored guest at Japanese Neurosurgical Society, South African Spine Society, and Portuguese Neurosurgical Society, visiting professor to Japan, Switzerland, USA, Portugal, IIT Kanpur, Manipal University of Health Sciences, National Institute of Neurosciences, Kolkata. 271 guest presentations, including Congress of Neurological Surgeons, USA, and World Federation and Neurological Society, USA, and Belgrade. And Asian Congress of Neurological Surgeons, he was adjunct the professor, IIT Jodhpur, adjunct professor. Sir, if I would like to continue, it will run to another half an hour, but I would not like to stand between you and his lecture, so I would request him to kindly address the gathering. Thank you very much for that.
Good morning. It's an honor and privilege for me to be here. Yesterday, when I was just boarding the flight, ma'am said that please send something. So there was one thing on my computer, I just sent that. I never expected it to be exhibited here. But thank you, it's an honor and privilege for me to be here. And I congratulate the entire science and technology fraternity of India on the 55th Foundation Day of the Department of Science and Technology. May I have the slides, please? Yeah. And the pointer. Yeah, change it. So I have presented in Delhi a couple of times, and each time, once at the National Science Day, the second one was at the INSA meeting, and each time So actually the password got stuck there. So I've taken all these lectures, but this time I thought I'll talk about, every time it's like a general thing. Basically it's for students. But I thought in this gathering of people with science and technology background, I would actually like to speak about neurosciences and where we are in neurosciences in the country, what the future holds for us, and how it is extremely important for us to actually focus on digital technology in neurosciences. This is something which I'm very worried about because most of the medical colleges are not really focusing on, they are still on those conventional things and not really on the digital technology in neurosciences. So I thought now in science and technology, we need to actually take it forwards. Sorry, shall I come there? I'll come there? Let's come. You've been able to open it? Oh, I'll come. Just one. So first of all, I'd like to thank the Department of Science and Technology, Professor Karandikar, Professor Dr. Dhanalakshmi, and everybody else who has been closely associated. You cannot imagine what a learning experience it has been and how honored I feel to be a part of this wonderful family here. So I'd like to talk to you about, why is this? Yeah, so I'd like to talk to you about digital technology and neurosciences. Where are we going? Quo vadis. So, why this? So the important thing here is that whatever that is within the realms of one's imagination is actually true. And whatever one can imagine is real. This was actually spoken by Pablo Picasso. And so this is the Guernica, which is related to the Spanish War. He gave it in 1937. This painting was made, and such a fantastic painting, and it is all coming true every time we have wars in the country. And you see his self-portrait. So when he was in 1896, he made a self-portrait, and this is his self-portrait when he was 91 years old. So the important thing is that a lot of things, so there is something which you do as a person, there is something the observer actually does as an observer, but there's another aspect to it, which is the interpretation of what is going on. So these three things, and interpretation changes, and therefore everything else changes. Sorry, this is not. So the technologies that I am mentioning in neurosciences are those that are already being clinically used in India. Sorry, can I just, I need to coordinate this. Can I say next slide, please, and you will do that? Okay, so next slide, please. So you see, this may not be scientifically absolutely true, but brain, of course, has the left side and the right side. And when you have the left side, which is basically responsible for calculations, analysis, decision making, and the right side of the brain is basically involved in in arts, in sociology, in public interaction, and it goes on like this. And all of us at some point in our lifetime have stood on one leg. So if you stand on one leg, you can't sustain that standing for a long time. So even in this presentation, if I'm only focusing on the left side of the brain, it's not really fair to you, because soon you will lose concentration and you will get tired. So I'll also concentrate on the right side of the brain and actually focus on that. Next slide, please. So these are, this is not a photograph taken from the net. These are my two dogs. And they are the most indisciplined dogs you can ever see. I mean, they will climb into the bed, they will get into the razai, and they will, at 5 o'clock in the morning, they'll climb all over me. Please take me for a walk. And SGPGI, where I was working as professor of neurosurgery, so every day, imagine two dogs on your head saying, hey, why are you sleeping now? Let's go for a walk. So every day I would go for a walk with them, both of them. And while they would enjoy the walking, I had a camera. And SGPGI is a 550-acre campus. So in that campus, I took photographs. And next slide, please. So the photographs, all the photographs, 500 photographs. Can you please go back? Don't change it till I ask you to. Yeah, so all these photographs came in a book, which is a kaleidoscope of campus colors, which has 500 photographs. And I'd also like to share with you some of these relevant photographs which actually appeal to the right side of the brain. Next slide, please. So, you know, whenever you see a Nilgai there, it's always associated with this duck or whatever it is. And so, you know, always they're together. So if one wants revolutionary changes in science, people with extremely diverse backgrounds and no apparent connections should actually come together, and then only science progresses. Next slide, please. So I'd like to tell you about magnetic resonance imaging here. And you see, it started with just looking at the anatomy. But as more and more sequences of these magnetic resonance imaging started emerging, we found that we could actually distinguish between different pathologies. Like, for example, you could distinguish brain abscess, where all these sequences show a brain abscess we can diagnose. We can diagnose multi-infarct state. You see those white things. They are multi-infarct state you can see. You can see an aneurysm, which is a weakness in the wall. All these sequences, different sequences, as they evolved in magnetic resonance imaging, we could actually see more and more. Next slide, please. And the other very important thing is we got another set of sequences, which is the three-dimensional constructive interference in steady state, where the cerebrospinal fluid comes as white, and the tumor, which is the arrow, comes as black. So you can clearly distinguish the cerebrospinal fluid from the tumor. And when you look at the other side, so these are patients who have tuberculoma. And there is a sequence, special sequence, which is known as magnetization transfer sequence, whereas you can clearly diagnose if somebody has those enhancement, it is likely to be tuberculosis. So imagine just by digital technology, simple digital technology, in maybe 15 minutes, you can actually diagnose diseases which are present in the brain. Next slide, please. So I was just there, and you see this board here, and this Neil guy was just looking at me, probably looking for directions. Maybe I don't know which direction the person wanted to go, and that's what we are all doing, looking for directions. Next slide, please. So this is a patient who had this white thing is a tumor. And when you look at the third image, axial image, you see that white thing around that black thing. So that black thing is the tumor. The white thing all around is the swelling of the brain. And this is very important because even when we have removed the tumor, the swelling of the brain can actually cause problems. It can cause neurological deterioration and lack of recovery from after surgery. And if you look at these post-operative images, you see that there's a white patches which are coming in the black. So that black thing is the brainstem. And those white patches is the edema in the brainstem. So this patient, despite that complete tumor removal, had some compromise of the vascularity, because of which he did not improve to the extent that we wanted him to improve to. So you can imagine that using digital technology, we can actually make out whether the tumor is actually infiltrating close to the brain, how important it is to the brainstem, how much of swelling in the brain there is, and when we remove, which tumor is likely to result in complete improvement and which tumor is not likely to result in complete improvement. Next slide, please. So this is a tumor, the same tumor. So you see, in digital technology, we have high operating microscopes, which are like any hair looks like a rope. So those, and you see, this is the layers of the brain, and this is the cystic part of the tumor that cerebrospinal fluid is being removed. And you can see that this is very high magnification. And those cranial nerves also you can see, and then the final part of the tumor which is being removed. So when you actually gently remove the tumor, so there is a layer which is all around the tumor, and you see that this is being removed from, this is a special technology which is known as ultrasound suction aspirator, so that they can completely decompress the tumor, and then it comes out from the surroundings. And this is the facial nerve that you see. This horizontal structure that you see is the facial nerve. And this facial nerve, if this gets damaged, then the patient's becomes facial asymmetry happens, so the patient becomes like this. So you have to be very careful in preserving this nerve, and this is very high magnification. So you can imagine how much digital technology actually helps you in all the science and technology and medicine that you are doing. Next slide, please. Now, another very important thing which has come up, which really helps us in surgery, is spectrography. So brain has gray matter, which is the surface area, which is the gray matter. And there's white tracts, you see B, G, they are white matter, and they are oriented in one way. And there are sequences of magnetic resonance imaging, wherein what happens is water comes like this, and these tracts are oriented in one direction. And if you assign a color coding to the vector of these tracts, you can actually decide where the tracts are. So this is the pyramidal tract, which actually is responsible for movements of the hand and everything. Next slide, please. And therefore, if there is a tumor which is actually infiltrating, you see the top cut where you see the arrow, suddenly the pyramidal tract on one side is completely obliterated. So you can actually make out that this patient is not likely to improve in his hemiplegia simply because the tract is completely infiltrated. On the other hand, you see the swelling all around in slide B. So this tract is not getting distorted, which means this patient after tumor surgery is likely to improve. And you see the third, where the tract is actually displaced, but not completely improved. So you can actually even know whether the pyramidal tract is likely to cause neurological deficits using these tractography features which come in. Next slide, please. So these are cats there, and this is the mother cat and two daughter cats. And you see how carefully they avoid trouble, okay? So first the mother looks around, then she walks across, then the two daughter cats are always walking across and then looking at avoiding trouble. Next slide, please. So now what happens is, when we are operating in the brain, we need to know where the tract for hand is, where the tract for speech is, where the tract for language is, where the tract for understanding is, where the tract for vision is. And how do we do it? So what we do is, supposing we have repeated movements of the hand. If we do repeated movements of the hand, some areas of the brain develop increased metabolism because those areas are now functioning. So when they are functioning, what happens is, from the arteries to the vein, the oxygen is actually taken out. So what happens is that the hemoglobin which goes in the red blood cells, it becomes blue because the oxygen has been taken out, and this results in an MRI signal, which is known as blood oxygen level dependent signal. And because of that, we know that this area is actually functionally more active when we are moving the hand, or when I'm speaking, there is a separate system. Supposing you're playing music, there is a separate areas get lighted up. If you are speaking something or reading, separate areas get lighted up. And based on that, you can actually decide where it goes on. Next slide, please. So what happens is, when you take photographs, if you just walk across in a garden, you don't really realize the nuances of what you're seeing unless you come close to it, you get involved in it, and you see this flower has so many beautiful nuances when you actually go close to it. Next slide, please. So what happens is that when we actually use this digital technology for tumors, we can do spectroscopy, which means that you can get a spectral graph of what the components of that particular tumor is. Now the advantage of that is that each frequency, when you send a magnetic signal, some of the components will start resonating, and that will give a graph. And when you give the graph, each tumor has a different graph because these components resonate at different frequency. Next slide, please. And therefore, when you have a low-grade tumor, supposing you have a low-grade malignant tumor, when you look at this, astrocytoma is the most malignant brain tumor known to mankind, which means that if somebody has a diagnosis of glioblastoma, the average lifespan is somewhere between 8 months to 1.5 years. So here also there is a huge variation, and it's not like a death sentence. So using spectroscopy, you can make out whether it's a low-grade astrocytoma or it's a high-grade astrocytoma based on the spectral pattern of the components within it. This can be used for anything. You can use for crystals, you can use it for substances, but you can also use it for the human brain non-invasively to actually find out what the tumor is. Next slide, please. So you see that glioblastoma is the most malignant tumor. And low-grade astrocytoma is like, so you can actually look at the voxels of the MRI, and based on those voxels, you can actually find out whether it's an astrocytoma, whether it's an intermediate glioma, or whether it is a brain abscess, and whether it's a glioblastoma, which is the most malignant. And the biggest change that we see is a change in the choline-creatinine ratio. Why does this happen? Because choline will come out in the tumors which are rapidly multiplying. So if it's a glioblastoma, choline will go high, whereas creatinine will go down. And another very important thing which happens is that lactate will increase because anaerobic metabolism occurs. Because what happens is suddenly there is a multiplication of cells, and the oxygen of the tumor is not able to keep up with that multiplication of cells. So therefore, suddenly there is a change in the chemical composition of the tumor, which you can actually diagnose. Next slide, please. Sometimes when you are in the garden, you actually see this is a leaf which is almost drying up. And you see the petal of the leaf, you see that, you can see that something has fallen off, something and not. So there are some beautiful designs, beautiful unseen advantages which actually come up when you are using digital technology. Next slide, please. So what we did was, you can do a tumor contouring with digital technology. You can do a reconstructed three-dimensional model using digital technology. So if you have done this, then if you are giving medicines, or if you are removing some tumor or something, then you actually know what is the amount of tumor there is, what are the contours of the tumor, and what is the extent of resection that you have done. Sometimes what happens is, when you remove a tumor, you don't want to remove it completely, because it is very close to a very eloquent area. So if it is very close to a very eloquent area, then what you do is you leave a little bit of tumor and then give radiotherapy or chemotherapy. So all that you can actually determine using digital technology. Next slide, please. Now, these were, and many of you have seen this parrot plant, and you see how beautiful the colors fuse with each other. And next slide, please. And what we can now do is, supposing you have taken MR imaging, then you have taken a CT scan imaging, you have taken a positron emission tomography imaging. Positron emission tomography means you send radionuclides into the body, and you take an imaging of the radionuclides which are in the body. And then what you can do is, you can match nose to nose, forehead to forehead, scalp to scalp, eye to eye, eyeball to eyeball, and you can overlap the images on each other. So which means that a CT scan gives you anatomical imaging. The MRI gives you soft tissue imaging. Positron emission tomography gives you a functional imaging. You have this, so therefore you can actually fit all of them in one thing and actually get a very nice, important thing which actually shows you all the different types which are actually present in the body. Next slide, please. The other important thing is that you can also do one very interesting thing, that is, if you put EEG electrodes, encephalography, so brain has electrical signals. Now you can put 200 electrodes, you can 250 electrodes, you can 500 electrodes. When you put all those electrodes on the brain and take electrical signals from all parts. Now, if there is a part of the brain which is epileptogenic, from which epileptic signals, abnormal electrical signals are coming out, which is causing epilepsy. You have all seen epilepsy, right? It goes, that patient goes like this, becomes unconscious, falls, injures himself or herself. And at that time, if you take all those signals and then give it color coding, okay, from this area, there are some abnormal signals coming. And then overlap them on a normal MR imaging. And then you can actually see anatomically where that abnormal signal is coming from. So this is known as magnetic source imaging. So using digital technology, not only can you just see anatomy, you can actually see functional waves which are also taking place. Next slide, please. Now, these are like, you never notice these beautiful colored features, the caterpillar and the snail and the slug and centipede. You never see them, but when you come close to them, there are so many things that you can actually see the colors of nature, which normally you would never even notice. Next slide, please. So now what you can also do is you can actually measure the cerebral blood flow, and you can see the cerebral blood volume in the tumor. So you can give that color coding also, and once you give that color coding, then you can actually see how vascular the tumor is. So supposing you say how many units of blood have to be donated by the patient, you can actually estimate the amount of blood which can be donated by the patient simply by seeing how much is the cerebral blood flow, how much is the cerebral blood volume in this. Next slide, please. And of course, this was, there were some lights, neon lights, and it was giving a beautiful picture on the bargat tree. And of course, this is a fallen tree, palm tree, so you can actually see the striations in the fallen palm tree. And therefore, sometimes, you require some intelligence also. So artificial intelligence also comes into it. Next slide, please. So now what you can do is, with all these digital sequencing that are coming out, you can actually train your machine with machine learning to not require a radiologist. What you need is you to have to go on giving, giving signals to the machine, and there is self-learning in this machine. So after some time, when it collects all the signals together, it can actually diagnose so many diseases. It can diagnose neurological diseases where surgery is not required. It can diagnose surgical diseases where surgery is required. It can diagnose those diseases which are completely amenable to therapy using treatment. So this is a very, very important thing where artificial intelligence comes in with all the images that you have. But one thing you have to remember, that when you are actually playing with artificial intelligence, the data that you give to the machine to learn itself has to be absolutely genuine data. Because if it is not genuine data, then it will learn wrongly and give you a wrong diagnosis. And here the biggest thing is, sensitivity is very important, because even if one case is diagnosed wrongly, it's a big issue. So supposing I have cancer, and the doctor says, no, you don't have cancer, and later on it comes out to be cancer, it's a big disaster. So you have to actually train the machine to learn properly and take it forwards. Next slide, please. Then another very important thing, this Sri Chitra has developed. So what we have done is, we have taken normal MR sections, all sequences, and then we have reconstructed using simple glasses that you get those blue and red glasses that you get, and with normal projectors on a normal screen. And you can actually reconstruct the entire MR imaging into three-dimensional images. Now the advantage of this is we have actually sent it to all the medical colleges of Kerala. And the advantage of that is when we have sent it to all the medical colleges of Kerala, then everybody is now learning anatomy in 3 dimensions. And I would like to actually one day demonstrate this particular technology, which is done with normal projectors on a normal screen, and the entire MR image can be actually converted into 3 dimensions. So and then now gradually we are moving on to disease things, like for example, and then you can segment it in any way, you can rotate it any way, so that you can actually see all around and actually come to a conclusion on how you have to plan surgery. The next slide, please. The other thing is, when we are looking at tumors now, we no longer look at only the histology. Okay, pathology is saying this. No, we don't do that. What we do is, we do immunohistochemistry. Immunohistochemistry means we actually subject them to many, many other different patterns. And in that immunohistochemistry, we can actually then diagnose the grade of the tumor, the malignancy of the tumor, the extent of the tumor. And now it is not required. Immunohistochemistry is not required because artificial intelligence-driven classification of gliomas does not even require molecular testing. So you just take a patient to an MR scan. With a digital technology, you can actually get immunohistochemistry of the tumor, and you can actually diagnose and see the extent of malignancy and how it is going on. So see how all these digital technologies has actually taken over entire pathology, has taken over entire molecular medicine, and it is now progressing further. Next slide, please. Another very important thing that we have is this gamma knife osteotactic radiosurgery. Here what happens is that supposing there's a small tumor, less than 3 centimeters in size, or we have removed the entire tumor but just kept the capsule there. Then we take it to the radiation suit where there is a helmet, a lead helmet, and that has multiple collimeters. And so one specific point in the brain gets focused radiation. And normally, a brain is only given say 5,000 of 50 grays of radiation. But here, you can actually, rather than 5 grays of radiation, you can take it to 25 to 30 grays of radiation for only 3 centimeter size tumor, which skips the entire rest of the brain. So this means that very high radiation is given to one spot, and that completely takes care of the tumor without actually undergoing surgery, without the patient undergoing surgery. So this is a big, big advancement in neuroscience which is taking place, and all because of digital technology. Next, please. So you put the patient in a helmet. These are all collimeters. For one focus point, there's radiation coming from all over and actually causing a complete destruction of the tumor without taking it any further. Next, please. The other thing is when we are doing surgery, sometimes the tumor is completely infiltrating into the normal brain. We don't know where the tumor is, how it is infiltrating into the normal brain. So in that situation, we can actually do a digital imaging. We can overlap the preoperative images on actual MRI images. And once we, and in the surgical field. And once we do that, we know, the MRI had shown that this is where the tumor is, but we have only been able to remove this much. So much more tumor is still remaining. So this is very, very useful that we can do. Another thing is, when we are clipping aneurysms, next slide, please. So this is a weakness in the wall. You see this round thing, balloon-like thing. So we exclude it from the circulation because if it bleeds, 1/3 of the patients die at home. And now when we have clipped it, how do we know that the vessel is still functioning? We can actually put dye and see. But with artificial intelligence, we can actually, without putting dye, during surgery, we can see the patency of the blood vessels. We can see how much of aneurysm has been clipped and how it can go further. Next, please. So this is a perfect image. So near the parking lot in SGPGI, we had these two perfectly symmetrical Neil guys sitting. So the yin and the yang. Next, please. So now what we are doing is, we take preoperative images. And we place them in the surgery in 3 dimensions. And then we have a digital camera. So this is when the digital camera is focused on the patient, then looking at the patient's contour, the camera and the computer can find out what the exact location of the patient is. So therefore, when you're doing surgery, next slide, please. So when you're doing surgery, so these are those 3 markers, these are known as 3 glyons. They are known as glyons. The camera can see that. And as soon as the camera can see those glyons with triangulation, it can actually tell you the exact position of the tumor and where you are during surgery on the preoperative images. So you know exactly where you are to the last 1 millimeter when you are actually doing surgery. So this is like a big advancement. This is known as neuronavigation. And every sophisticated neurosurgical center has neuronavigation within it. Next, please. So not only can you do neuronavigation, you can actually superimpose colored images of a preoperative image on the actual operative site. And so you have removed this tumor, and still there is tumor. You can see that green thing, and then you remove more, and then you say, okay, a little bit of purple still remains, so remove that area also. So you have neuronavigation which guides you where it is, and you also have color images which can actually guide you during surgery. Next, please. And all this is digital. So you can actually, if you touch a point there, on 3 dimensions, you get these cursors which tell you exactly where you are in terms of very, very important areas. The blue colored area is the internal capsule, where fibers of the sensory system, fibers of the motor system, fibers of the vision, and fibers of the speech go together. So in that small area, so we know exactly where we are in terms of that blue area there. Next, please. Now, sometimes you look at this cat. So this cat was like not friendly at all, but really photogenic. So we have to assess for solutions from different perspectives. So next, please. Next slide, please. So now what happens is, when you are doing surgery, you have neuronavigation you have done, and now you know exactly where you are in the brain. But 2 things happen. You have removed the tumor, so the brain shifts. And you have drained cerebrospinal fluid. Again, the brain shifts. And the shift is from 7 millimeter to 1 to 1.5 centimeters. So which means when you are actually putting a probe there, then actually it's not accurate, because the preoperative images are showing a different point and the actual image is different. So you have intraoperative MRI and CT scan. So you can take the patient for an intraoperative MRI and CT scan. Many centers have this, even in India. And so you can just wheel in the patient, do a real-time image, and again send those images to neuronavigation. So whatever is the brain shift, you actually can compensate, and you know exactly where you are in relation to the real-time images that you get of the patient. Next, please. So troubleshooting is the next thing. So this was one fire. There's a big jungle there. So there's a fire in the night. And you can see the moon. So when a beautiful moon there. So even in the presence of fire, there is always an escape route and some solace somewhere. Next, please. So what happens sometimes is that you think you have removed the tumor completely. But there is residual tumor, or tumor comes back again. Or another very important thing is that you think the tumor has come back, whereas it is just an enhancing thing which will go away after some time. So you don't want to subject your patient to further surgery. So this is known as pseudo-progression. And we have MR images which can actually, with spectroscopy, with all the images that you see, you can actually decide whether the tumor has actually come back or it is just some enhancement that is seen and it is not real tumor which is taking place. Next, please. And of course, we can entire thing, so metastasis, like you have multiple metastases in the body. Now, there are multiple lesions. So when you do the entire sequencing with spectroscopy, with all types of images, you will exactly know whether it is what type of metastasis, where it is. You can get a histological diagnosis, you can get a molecular diagnosis, and take it further. Next, please. Now, what happens is, let's come to the macro world. You see, I took photograph of this canna and this hibiscus, and I didn't realize that those beautiful, water droplets here, and that I didn't see that small insect there. Now, so let's enter into the macro world of tumors. Next, please. So metabolics. So when you look at the digital technology, you can actually in tumors know the metabolism of tumors also. So for example, in toxic and metabolic disorders, you can actually see this also, the metabolics in MRI. Next, please. And you can actually, with MRI, you can decide what components they are. And based on the components, you can see what the sensitivity is. And you can see encephalomyelitis, infection, rabies, histoplasmosis, Lyme's disease. All these are neurological diseases which you can diagnose using MRI and look at the sensitivity and specificity. It is as good as histology. Next, please. Now, this is a very interesting thing. So all of them were my pets. So one day we had kept this dog's bed to dry, and this cat went and slept there, and my dogs were very furious. And look at the other one. You see, they are siblings, and they're just hiding behind, and you can see the expression. They are a little afraid. This cat, I would feed her every day, and now she's looking from the rooftop, and I was going to the hospital, and she says, "Hey, where are you going? You're supposed to feed me. Don't go." See the angry expression there? Look at these three. One is an albino cat, and all of them, they're all siblings. So they're just posing for me. And of course, these are my young, when they were very young, wanting some food. What is the common factor in all these slides? It's cognition, okay? Expression, emotion. Animals also express emotion. Human beings express emotion. Next slide, please. So in cognition, we can actually find out the consciousness level. We can look at the memory. So this area is known as the amygdala. And you can actually see the memory using this. So you can actually see cognition, you can see memory, you can actually see speech. And you can, sometimes they say, you can differentiate between love and hate using functional MRI. So I don't know that, but I'm just telling you that this is the future. And it's very dangerous. It's not simple. It's very dangerous because imagine an MR scan here which actually tells you, well, you are getting bored with my lecture or you're very interested in it. So it's very dangerous. Next slide, please. And now what happened was I came after a long day surgery, very late in the night. And it was almost 9-10 hours of surgery. I was very tired. And then, this web was shining against the light. So I just took a photograph and forgot all about it. And then all these ants were there. I just took the photograph and forgot all about it. Then later on, I just looked up in the bigger screen of on my computer. And suddenly I found, oh, there is you see the spider there at the end of it. And you see all those beautiful yellow leaves of gulmohar tree, which are caught in the web. And you look at this queen ant, which is surrounded by all the other ants. So there are like many, many nuances to nature, which you actually look at. Next, please. So now what we do is, in Chitra, we are doing a lot of surgery for epilepsy. So we are actually resecting normal brain. So when we are resecting normal brain, how do we resect normal brain? So we put these grids there, and they're all numbered. And then we actually take electroencephalographic channels from it. And once we take those electroencephalographic channels from it, then we actually know, okay, this part between number 1, 9, 2, 8, 10, this is abnormal. Then we can actually take it out and remove it. So we have actually made these electrodes, and now one company has just bought it. This time, we are translating these electrodes to one company. Next, please. And you can get multi-channel, and then you know which is the abnormal area. You can resect that area, and the tumor and the patient becomes completely tumor-free. Next, please. Another very important thing is Parkinson's disease. I'm sure there are many elderly people in your family who have movement disorders because of Parkinson's disease and because of other diseases. So what we do is, we stereotactically implant various electrodes into the brain, in the subthalamic region, in the substantia nigra region, and a pacemaker is placed in the subcutaneous tissue here. And using that pacemaker, with these direct signals, you cannot recognize that the same person was one who was like, 5 minutes ago was walking like this, and then suddenly he becomes completely normal. And the funny thing is, as soon as the battery goes down, he comes back to that same stage. He becomes like, crouching, movements, he's not able to speak. And then suddenly, you stimulate, he becomes normal again. So we have actually also made the deep brain stimulation, which is probably going to be the most sophisticated biomedical device ever made in India. So this we are in the process with Bhabha Atomic Research Center. We have collaborated to making it, and we are going to translate it this year. The expression of interest is already on the website. Next, please. And then we can use digital technology for endoscopy. Now you don't have to use big incisions, big craniotomy to do your surgery. You can put a small endoscope into the brain. Next slide, please. And so this is a tumor. The yellow thing is an intraventricular tumor, which is known as a craniopharyngioma. So I just put an endoscope inside and then done a biopsy, and we have also created cerebrospinal fluid, and you can see the basal blood vessels after the tumor has been removed. So even with very narrow 3 to 5 millimeter endoscopes, you can actually remove all the tumor. Only an incision in the eyebrow, or a small incision here, maybe 1 centimeter incision, or a very small incision, 2 centimeter incision to remove the lumbar disc. All those things are possible now. Next, please. So this is a very interesting story. I had taken photographs of 500 animals, but this fox was foxy, and I couldn't take a photograph. Whenever I would come, he'll run away. And I could never take a photograph. So one day I was doing some written work, so I went at, normally I'm 8, I'm there at the hospital. But at 9 o'clock, I just was driving, and suddenly I see the fox eating something. And I stopped the car. And it takes some time to adjust your mobile camera and all that. And as soon as the fox saw me, went behind that elevation. And I said, oh my God, I missed this opportunity again. So I waited. Suddenly he thought, oh, there's no sound. Let me look up. And I got a perfect photograph, okay? And I'm very proud of this photograph. Next, please. So blending in the ecosystem is a very important aspect. So now, see, one is what goes on in the cell, but we have all realized that there are epigenetic changes which are outside the cell that we also have to look at. And using this digital technology, we can actually diagnose meaningful epigenetic changes of the cells, of the neurons, and all these aspects. Next, please. So epigenetic pathways. And another thing is, supposing somebody develops stroke, how does the patient recover after some time? Because there is a thing called neuronal plasticity. Other neurons take over the function of this person. So this is also a very important area which we can do with digital technology. Next, please. Now, this is a kingfisher, and this is a very rare bird. They are very rare encounters. So next slide, please. So now what we can do is we can put a small electrode into the brain, take out a small sample from it, and do a biochemical analysis, and this is known as microdialysis. And Shri Chitra is also making these microdialysis. So once we make this, then the advantage of this will be that you can actually put something in the brain and actually give a diagnosis. Say, for example, somebody has meningitis. You don't know whether it is tuberculous meningitis or bacterial meningitis or viral meningitis. You can actually go inside and take a biopsy and do an analysis. This is known as microdialysis. Next slide, please. And we also have optic neuroimaging that you can actually diagnose chemosensors using digital technology. So you can see how much of work is going on in all these areas. Next slide, please. Next slide, please. So now going on to, so you see these three birds were there, they were chattering, and then one flew away. Next slide, please. So drug efficacy is a very important aspect. So now in tuberculosis, we diagnose tuberculosis. When we give treatment, the tuberculosis disappears. Then there are some sequences which are known as magnetic transfer sequences. So that they highlight tuberculosis. So you can actually, using digital technology, see how the patient is responding to the drug therapy which is being given. So look at the revolution which is taking place in neuroscience as far as digital technology is concerned. Next slide, please. And of course, there are some strange things which can also be done. Next slide, please. So you can actually do complete cancer biology and receptor protein analysis using digital technology. Next slide, please. Next. So next slide, this. And of course, you can do 3D simulation. Next slide. So you can do 3D printing. So now we have developed, Shri Chitra has developed bioink for 3D printing for the first time in India, and this has also been translated. And so 3D printing, tissue printing can be done. But not only 3D tissue printing, you can do 4D printing, which means if you change the conditions of that print, suddenly the shape changes over time. And this is known as 4D printing. So not only 3D printing, but you can actually do 4D printing. Supposing you change the, you can give a polymer some change of time, change of shape, suddenly the entire thing changes. Next, please. So you can actually, in all spine, you can reconstruct the entire spine, you can reconstruct the blood vessels, and then we know what the shape is even before we are doing surgery, and we can do it using 3D printing, using 3D technologies. Next, please. In the spine, using digital technology, we can exactly put the pedicle screws in the spine wherever we want it. Those are important areas that we need to look at. Next, please. And now this is a very interesting case. This patient, we were doing flow analysis in Shri Chitra, and suddenly the patient died. And when the patient died, we did an autopsy, and we found that the flow analysis that we had predicted digitally was exactly the point where this aneurysm ruptured, because of which the patient died. So this we published, and so this is very interesting that you can actually do flow analysis using digital technology. Microfluidics you can do using digital technology. Next, please. And of course, simulation I've talked about. Next, please. And now organ on a chip. So we don't have to do all these animal experiments which we are doing. You can actually do a lot of modulation using microfluidics. You can, using 3D tissue printing, you can make all these organs. And after you make these organs, then you can do a digital simulation. And not only can you do digital simulation, you can actually put in toxicological agents, you can put in pharmacological agents, and see how the tissue is responding. So this animal killing all the time has to stop. It has stopped in most of the countries. It has now to stop in India. Next, please. And these are some of the other other inventions where you can actually do the modulations, and these are all prepared: aortic stent, annular ring, atrial septal defect, left ventricular assist device have all been made and translated in Shri Chitra. Next, please. The operating microscope that you use, what is special about it? It is like this. So it is a stereoscopic microscope. It is not a two-dimensional microscope, it is a three-dimensional microscope, whereas you can also do a depth perception using these microscopes. And I think now the time has come where, these fiber optic cables, these various prisms, the various lights, the optics, all of them needs to be made in India. None of them is being made in India right now. Next, please. Look at this craniophagus twins, so we could actually see what are the veins which are common, where the head is joined together using 3D simulation. Next, please. And proteomics, you can see the proteins of the cells can be seen. Next slide, please. So various proteins can be seen using various digital methods, spectroscopy and computer analysis. Next, please. Next, please. And so one of my students, he passed away, unfortunately. So he has this paper in Science where they have done for all the pituitary glands, they have done the entire proteomics and polypeptide chains, which was published in Science. From PGI Chandigarh, they have done it. Next, please. Next, please. So now the thing is osteoporosis, because bones do not come well on MRI. So you can actually diagnose osteoporosis. All elderly men and women have osteoporosis. And now you're doing this extensive bone scan, this and that. All that using digital technology you can take forwards. Next, please. Now, I was just walking in the corridor, and this mother and this baby wanted to come in. And I said, oh, it's not so easy to come in. It requires more effort, more time. So let me tell you some big unfinished problems which we really need to focus on. Next, please. So, next slide, please. Next slide. So this is what the sound of an MRI is. Many of you must have experienced it. When you are going into the MRI, the magnets change. And this is the sound which is produced in an MRI. So we need technology to muffle the sound. And we still don't have it. Okay, so it's very claustrophobic inside. Many people refuse to go in, and the sound is horrible. So we need to actually work on that. The second important thing is, within CT angio, when you put in an injector dye, we can see the aneurysm. But on MRI, that aneurysm is not accurate. So we are working on this 3D modeling, which I was telling you. From that, we are actually doing the segmentation to get to the aneurysm. Next, please. Then another very important thing is, whenever you put a metal construct, it causes a lot of artifacts on the soft matter. So you can see that it appears as if there is a compression, but actually there is no compression. So we need some technology to make sure that that artifacts can be minimized in all these bony, long segment fusions that we do. And this is very, very important. And in MRI, you can't take a patient who has a pacemaker inside. And this also, we need to actually develop technologies for it. Next, please. Then, of course, all the ergonomics of the operation theater, we need to actually rationalize properly. Next slide, please. Next slide. Then the videos, every surgery we should make videos, because there is so much of litigation now that we should actually make videos, digital videos. We should take very detailed records. And this also, a lot of digital technology is required for this. Next, please. Now, we are testing in animals this artificial heart, second generation artificial heart. We have implanted it in almost 41 patients. And now the important thing is, why should we kill animals? We can all do this by computer modulation and computer simulation. Then, in the end, maybe 2-3 animals are required. You don't have to do 30 animals, 40 animals for no reason. And next slide, please. And of course, during the COVID, this is a real thing. All of these were in Uttar Pradesh. I was in charge of the digital technology dissemination, where we were connecting all the primary health centers, secondary health centers to 3 main hospitals. So teleconferencing, teaching by teleconferencing, during COVID, we realized the importance of it. Next slide, please. Next slide, please. And you say, so all these sessions were going on during COVID. Every day we would go to all these people were in the ICU. They would give a feedback to the people, a central person sitting outside. And this is what we did. Next, please. Next, please. Now, very interesting thing happened. I was walking in the corridor, and there's this baby monkey, without understanding the dangers, without understanding anything. He was just going all around. I waited. When there was a perfect vertical downwards leap, I just took this photograph. But he is not aware of the danger, right? He's on the top of a tree and I'm on the 8th floor of SGPGI. So through the window. Next slide, please. So, you know, what is the important thing is whenever you're using digital technology, this is one important thing we have also faced in e-office. So data security and confidentiality is an issue. Accountability, who's accountable is a big issue. Patient sentiment, he's not really seeing the doctor. Then over-treatment. Oh, just because you see some change of image does not mean that you actually have to treat the patient. Then, of course, job loss, and of course, there's a lot of environmental issues. Whenever you are actually taking digital technology, there are lots of environmental issues which also take place. And so this happened in UK. So there was this young neurosurgeon who was learning robot surgery. And he had some mentors. So after the 4th or 5th surgery, they said he's pretty good at it. So they went to have tea. And meanwhile, he messed it up. So the robot actually killed the patient. So all these are issues which we actually need to focus on. Next, please. And of course, this was published from All India Institute of Medical Sciences, a very innovative work they did from Delhi. And what they did was, when the surgeon was operating, he was clipping an aneurysm or he was doing some surgery. They were continuously recording his pulse, BP, his perspiration, his stress levels. And he found that when he was dissecting the aneurysm, the BP went to 180 by 110. So if you look at all the general population, the doctors have 10% less lifespan. And all surgeons have 10% more less lifespan. We don't even realize how stressful it is. And these are some things which we actually have to continuously monitor using these technologies. Next, please. Now I come to the final part, which is related to some basic science and the advances which have come up. These are not present in India, but I just want to tell you a little bit about. So at 4 o'clock in the morning, suddenly, these guys, my 2 dogs, woke me up, and it was winter. So I went there and I saw this beautiful pattern created by these lights. So I'd like to tell you about this road less traveled by. Next, please. So one important thing which I'd like to tell you is, you see the problem. The problem is something which is unsurmountable at the present moment. So only in the cortex, okay, there are 17 billion neurons. And each neuron is given almost 1 spike per second. So in one lifetime, 34 billion spikes are taking place. In only this much of the brain, it has enough spikes and data to fill up all the libraries of the world. Okay, it has more data than all the libraries of the world put together. That's a very important thing. Now, how do we recognize things? So what happens is, you see these 2 neurons in the middle slide, and they are both giving a spike. And then they converge to the dendrites of another neuron, and from the axon, another spike comes. So supposing I'm making a movement, then all the neurons which are responsible for my making the movement work in cohesion. All the other neurons suppress the surrounding areas. And therefore, brain knows that this is what I have to do. You understand? Now, another thing which happens is that all these spikes can be plotted in this bar diagram, bar chart, and those pictograms. Now, once you do that, then you realize a very interesting thing, that there are some neurons which 10% of neurons are firing very rapidly. But 90% of the neurons are not firing at all. And spikes, these 10% are firing up almost 75% of the spikes. So what is happening here? What is happening here is that this develops a border. So if we recognize each other, how do we recognize each other? How do I know that a person is sitting here? Because in my brain, a border is established. And how is this border established? Because the vision is giving continuous input, the sound is giving continuous input, and there is a suppression of cells all around. So using this pattern, a border is established. And that border, the person sees as a separate person. The brain sees as a separate person. So this is what the whole thing is. So imagine how to measure the voltage of those spikes, how to make sure that they are all combined together. Then there are so many sensory systems. We are only talking about only 10% of neurons. It's a big issue. Next, please. Next, please. So this is the pattern which is established. So almost 90% of the brain is not functioning. Only 10% is functioning whenever you're doing an activity. And maybe it is basically because there is a pattern recognition. It is forming a pattern which the brain recognizes, and therefore it takes it forward. And of course, you see that even in that small thing, small, tiny thing, there are millions and millions and millions of neurons, which actually brain takes up 20% of your energy, body energy. The rest of the body takes 80% of energy. But in brain, if more than 3 minutes, if you do not supply oxygen, the brain dies. So therefore, whenever we are resuscitating a patient, we only have 3 minutes. Next, please. And of course, this is only 1,000 times thinner than a human hair. One mouse visual cortex was resected. And these are the 84,000 neurons and 500 million synapses are present. And how do you actually assess them? How do you assess the connectivity? How do you assess what is suppressed and what is not suppressed? All these are important issues. Next, please. Now, what MIT has done is, they have given chemical coding. So as soon as there is a neuron firing, you can actually see it firing and give a color coding to it. So exactly you know what are the neurons which are firing and what are not firing. So these are the advances in neuroscience which are come in this year only. Next, please. Next, please. It further complicates. When you come to the end or at the synapse, there is a chemical and electrical bond. And it's not only electrical. There is also a chemical being released, like acetylcholine is released, or adrenaline is released, or non-adrenaline is released. So how do you actually combine the two is another issue which we know nothing about in neuroscience. And then there is another thing. There is a graded response. It's not always all and none. Sometimes it will be a graded response. What is the implication of the graded response? Next slide, please. So sometimes, elderly person with a fading memory you have seen, but they will always recognize their family member. So what is happening? That there are some neurons which are aligned always to recognize your own family. But all the others you forget, but your family you will recognize. So that is one important thing. Then athletes, when they are practicing again and again, what are they doing? They are reinforcing their neurons to actually work in a particular direction, and this is also an important thing. Next, please. And sometimes, when you are very stressed out, as a director, sometimes there's a big crisis, this come, RTI and this and that, and then you say, okay, I won't take a decision. Why do you not take a decision? Because under the time of stress, what actually happens is, at the time of personal stress and anxiety, there is an over-exertion of some neurons, and this actually causes their suppression. This is like depolarization. So this is a very, very important aspect that you need to look at. That is why all mothers used to say, exam, relax, okay? Don't get stressed out. Because in stress, actually, your performance decreases. You understand? So these are all things which have come from neuroscience. We have been able to discover some of them. Next, please. Now, I'll just tell you about this Neuralink, Elon Musk's Neuralink. This is my last point. So this patient has a disease known as motor neuron disease. So what happens is all the motor neurons start degenerating in this person. Gradually, he becomes quadriplegic. But the cranial nerves are intact. So he can blink his eyes. He can speak. He can perform respiratory movements. But gradually what happens is, even the deglutition and respiratory movements are not able to be performed. So now he's on tracheostomy, and he can only blink his eyes. His tongue can come out because they are supplied by cranial nerves, and he can clench his jaw, which is also supplied by cranial nerves. Next, please. So what has happened is that there are almost 1,000 electrodes sprayed in the brain. All of them are giving electrical data. And then using that electrical data, wherever there is maximum amount of stimulation, they can actually look at the data and give signals. So now what he does is, whenever he moves his tongue, he can take the cursor to those, and he can type this like a computer. And whenever he clenches his jaw, it acts like a mouse. Okay, click of a mouse. With a jaw click, he can do that. And another thing which it does is, focused thoughts, it can differentiate between focused thoughts and random thoughts. So that it's not like only random thoughts are actually overburdening the focused thoughts. So this is what Neuralink is, and now we are going further with this. Next, please. So I'd like to end with 3 slides. The first of them is, interspecies communication is very important. What happened is that one day I was going for this walk, and this parrot and the squirrel were eating together. I said, oh, I have forgotten my camera. Then I said, okay, no mind, very good opportunity lost. The next day I went again, they were again there at 5 o'clock. I said, oh my God, I'd still not got my camera. The third day I went, they were still there. The fourth day, I took my camera and they were there and took this beautiful photograph. So there has to be an interspecies communication, which is very, very important. Next, please. Next slide, please. But what we are doing is interspecies confrontation. Look at the monkey and the nilgai. So they're actually fighting with each other for nothing, okay? I don't know what they're fighting for. So this continuous interspecies confrontation has to stop. We have to work together. Next, please. Now the other important thing is, so this was a beautiful photograph. A mentor is someone who allows you to see the hope inside yourself. And unfortunately, part of Indian mentorship is that we as mentors today actually do not know the advances of digital technology. So when we don't know the advances of digital technology, how can we mentor other medical students into progressing in digital technology when we ourselves don't know how to take it forwards? So this is a big gap which we somehow need to bridge. Next, please. The other interesting thing is, we see purple color. Ma'am is wearing a purple sari, some purple. Actually, purple is not a color. Okay. What happens is, red and the violet and you know, if you see red and violet of the Vibgyor, they are far apart. But when they are combined together, brain sees them as purple. Actually, there is nothing like a purple color that they have realized. So what is happening is that digital technology is actually giving you colors like this, giving you nuances like this. You think they don't even exist, the possibility doesn't exist. But somehow when we combine them together, it becomes a revolution. Next, please. So gradually, you know, from fog at the GPGI campus, a little bit of sunlight is coming. Next, please. Next, please. But the problem here is that this was taken at Kanyakumari. So I was at the hotel. I'm waiting for the sun to rise. The suspense is whether clouds will overtake, whether the sun will be perfect, whether I'll get that perfect shape or not in the morning. Right now, we don't know as far as digital technology is concerned. Next slide, please. So, next slide. So this is Enya, Only Time. A beautiful, please enjoy this song.
Who can say where the road goes, where the day flows? Only time. And who can say if your love grows as your heart shows? Only time. We can say why your heart cries when your love has only time. Who can say when the roads meet that love might be in your heart? And who can say when the day sleeps if the night keeps all your heart? Night keeps all your Who can say if your love grows as your heart shows? Only time. And who can say where the road
Thank you so much for your kind attention. Who knows? Only time. We don't know how this digital technology will emerge, where it will go, but we all need to be aware of it. We need to adopt it. We need to understand that unless we become adept at it, soon we will lose everything that we have today. We will lose India as it is unless we make sure that in every branch of science, digital technology becomes a learning priority. Thank you very much for your kind attention.
Thank you so much, sir, for this very, very, very comprehensive and educational as well as an entertainer lecture. I must say we are able to understand the importance of digital technologies, not only in understanding the human body's anatomy, the functionality aspects, as well as we enjoyed the beautiful pictures that you presented all through your lecture. So I, on my personal behalf and on behalf of the Department of Science and Technology, appreciate the thoughts that you shared with us. The success stories, I think, would go a long way in leading, in mentoring all of us as young scientists in the department and at the various autonomous institutions of the Department of Science and Technology. Thank you so much. And I think we must also request Dr. Bihari to share one or two copies of the Kaleidoscope, the book that you have published with the pictures. I think we can all consider having it in our libraries. And when we are tired with our day's work, we can go and have a look at them and get refreshed. Thank you so much, sir. It was wonderful. So we are awaiting the start of the inaugural. We are awaiting a message for arrival of the Honorable Minister. Request you all to be seated. We'll be coming back in a couple of minutes with more information. Request all to please be seated. We have the dignitaries with us now, and we will be commencing with the inaugural of the 55th Foundation Day of the Department of Science and Technology very soon. A very good morning to one and all. Ladies and gentlemen, dignitaries, it's our distinct honor to welcome the chief guest of the inaugural function of 55th Foundation Day of the Department of Science and Technology. Please welcome Dr. Jitendra Singh, the Honorable Union Minister for Science and Technology, Ministry of Earth Sciences, the Ministry of Personnel, Public Grievances and Pension. With his visionary leadership and unwavering commitment to national progress, the Honorable Minister continues to inspire a new generation of scientists, leaders, and policymakers across the country. I request all dignitaries to please join us on stage. Dr. Raj. Thank you all. May I now request Professor Abhay Karandikar, Secretary, Department of Science and Technology, to kindly present bouquets and extend a warm welcome to the dignitaries. I request the participants to come a little forward. There are some seats vacant here. This side, please, the people sitting at the back, please come forward. That's it.
In the heart of darkness, a spark we ignite, a flame of wisdom, a beacon of light. अंधेरों के बीच एक आशा की किरण जगाते हैं, ज्ञान की लौ से हम तमस को मिटाते हैं. To invoke an auspicious beginning, may I invite all the dignitaries for the ceremonial lighting of the lamp.
शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते दीपज्योतिः परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिः परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापं सन्ध्यादीपनमोऽस्तु ते ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः आरोग्यं देहि पुत्रांश्च मतिं स्वच्छां हि मे सदा रवेरस्तं समारभ्य यावत् सूर्योदयो
Thank you all. We would now extend a formal welcome to our distinguished guests with tokens of appreciation. I would now like to request Professor Abhay Karandikar, Secretary, Department of Science and Technology, to felicitate our esteemed chief guest, Honorable Minister Dr. Jitendra Singh Ji, as a token of gratitude and respect. They are getting. Thank you, sir. Thank you, sir. I would now like to request Shri Sunil Kumar, Additional Secretary DST, to felicitate Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India, as a token of our appreciation and respect. I would now request Shri Sunil Kumar, Additional Secretary, to felicitate Professor Abhay Karandikar, Secretary, Department of Science and Technology. Okay. Okay. I would request Sunil sir to please felicitate our honored distinguished guest, Dr. Adil Zainul Bhai, Chairperson CBC, as a gesture of our gratitude and respect. Thank you, sir. May I now request Madam A. Dhanlakshmi, Joint Secretary, Department of Science and Technology, to felicitate Shri Sharat Sharma from CEO DST Foundation as a token of our appreciation and respect. I also request Madam to please felicitate our Honorable Secretary, Department of Science and Technology. Thank you for all the support. Thank you, ma'am. I now request Secretary Sir to deliver the official welcome address.
Honorable Union Minister for Science and Technology, Dr. Jitendra Singh Ji, Principal Scientific Advisor to the Government of India, Professor Ajay Sood, Dr. Adil Zainul Bhai, Chairman of Capacity Building Commission, Shri Sharat Sharma, DST Foundation, and our today's keynote address will be given by him, and the Foundation Day lecture will be given by Dr. Adil Zainul Bhai. My colleagues from DST and our autonomous institutes, directors of various autonomous institutes, and other distinguished dignitaries and invitees, ladies and gentlemen. First of all, let me begin by extending my very warm greetings on the 55th Foundation Day of the Department of Science and Technology. Since its inception in 1971, the Department of Science and Technology has played a pivotal role in transforming the scientific ecosystem of the country. More recently, in the last few years, the department has taken many transformative steps to not only energize the R&D ecosystem of the country, but also to inculcate innovation and entrepreneurial spirit in our young innovators through various missions, through various R&D programs, and through various incubation and startup supporting activities. In the last few years, we have taken some game-changing initiatives. Anusandhan National Research Foundation is one of them, and several path-breaking missions like National Quantum Mission, National Mission on Interdisciplinary Cyber-Physical System, and various other R&D programs and support systems for incubation activity have really had a profound impact on the entire scientific ecosystem of the country. For these scientific achievements, I would not only like to congratulate the entire scientific fraternity and the scientists and researchers, but the officers, colleagues, and scientists of the Department of Science and Technology who have been instrumental in supporting various activities, various research and innovation activities of our scientists, not only in DST and its autonomous institute, but also in various academic institutions, universities, and institutes of national importance. As you know, that Department of Science and Technology is one of the largest extramural funding agencies in the country, and therefore, the R&D programs of various academic institutions and universities to a large extent depend upon the support provided by the DST and the other bodies such as the erstwhile SERB, ANRF, and the Technology Development Board. Through its various activities, we have truly inculcated a spirit of working with our scientists and providing them the much needed support that our researchers in the country need to perform path-breaking discoveries. I believe that the sincere efforts of all of my colleagues in the DST will be acknowledged in the days to come, not only by our scientific communities, but by the transformative changes that we are bringing in this entire ecosystem. I would like to congratulate all the DST colleagues, both past and present, who in last more than 5 decades have been continuously striving to improve our innovation ecosystems, and now we see that we are making those many transformative changes. Once again, I would like to extend my warm greetings to all of you, and I hope on this auspicious occasion, we can commit ourselves to making our country a science and technology superpower in the years to come, in next 25 years, when we realize the vision of our Honorable Prime Minister of becoming a developed nation, a Viksit Bharat, by 2047 on the pillars of science, technology, and innovations. Thank you very much. Jai Hind.
Thank you, sir, for your inspiring and valuable words. It is our great honor to have Dr. Sharat Sharma with us today. Dr. Sharma is the CEO of iSpirit, Indian Software Product Industry Roundtable Foundation. With over 3 decades of experience in the internet, enterprise software, and digital infrastructure sectors, Dr. Sharma has held senior R&D roles at companies like Yahoo, Veritas, Symantec, Lucent, and AT&T. It is my privilege to invite Dr. Sharma to deliver the keynote address.
Thank you so much for inviting me. And, I think in the next 20, 25 years that we are looking at, the role of science and technology is going to be extraordinarily important. I think it's been important all along, but you know how the world is changing around us, the geopolitics, the global order, and in this new world, our ability to pivot to an economy based on science and technology is going to determine whether or not we'll be an important country or not. And so therefore, the work that all of you do and is going to become more important than it has ever been in the past. And I think the foundation that has been laid in the last 55 years will come handy in building in an accelerated way as we move forward. So I have a set of slides, and hopefully they'll come up. And I want to walk you through a story of the last 10, 15 years. And motivation is to extract from that story some lessons learned, which I believe will be very useful for the next 20, 25 years that we're looking at. And this is a conversation, and I'm hoping that these lessons that emerge from it, you'll not take them as gospel, but rather, merely as a provocation to think for yourself as to what is the best way for India to become what Dr. Ajay Sood here calls as a product nation. And so this is really what it is. And if there are slides, well and good. But otherwise, I can walk you through this without the slides as well. They're coming? OK. So I'm going to tell you a story while the slides come. I'm going to tell you a story, a very simple story, which actually started many years ago. And some of you have probably heard this. This is to do with a street vendor in Bangalore. Her name is Rajini. And this is a revolution that has unfolded to actually meet the needs of Rajini. And what is that revolution? Rajini takes an intraday loan. Intraday means 1 day loan for, let's say, 1,000 rupees, pays 1% for it, which is 10 rupees. And if she keeps that loan for 2 days, then 20 rupees. If she keeps it for 300 days, 300 rupees, right? I mean, so it's 300% is the kind of an annualized interest rate. The goal was, back in time, to bring her into the formal system. And not only to bring her into the formal system, but to do it in a way that she is not paying more than 30% annualized interest rather than 300%. So in other words, she gets a loan of 1,000 rupees and she pays only 1 rupee a day. Now the question is, if you have to subsidize it, it was possible. But if you have to do it with market forces working, you had to reinvent the way we thought of digital. And therefore, her work became very important. And so if you really wanted this to happen in the context of the market, which is an important consideration, you needed to make sure that there were building blocks that were available that would allow her to, or allow the market innovators to not only do delivery of service, but also make money on 1 rupee a day that they would get from her. So this basically required us to reinvent the building blocks of the internet. You know, all of you are technical people, so you know the building blocks of the internet as we know them today. They are flow of packets, which is TCP/IP, flow of messages, which is used in our email, SMTP, and flow of web content, which is HTTP. You know about that. And that does allow, let's say, a young girl, in Haryana to learn a new language if she so wants on the internet. But it doesn't allow very easily for that same family to book a railway ticket. Because when you book a railway ticket, many other things come into consideration. One thing that comes into consideration is you have to identify yourself. Because when you board the train, they'll actually check, are you the person whose ticket this is, right? So you have to identify yourself. You have to select from many options, which day you want to travel, which train is cheaper, what time is there a seat available? So there's a personal information being shared and something coming back to you. And finally, you have to make a payment. So back in time, about 10, 12 years ago, it was clear to us that if we didn't reinvent the flow of people, flow of money, flow of information, we will not get the result that we want. Now, why is it important to reinvent this? Because in these three flows, there are people sitting in the middle, middlemen that are there. Those middlemen can be like the postal system. The postal system is a public utility. The postman doesn't know what's inside the letter, so doesn't charge you based on the importance of the letter, charges you based on the weight of the letter. So that is one system that you have that's actually used for the first internet that I talked to you about, flow of packets, flow of messages, and flow of web content. Or you can have a system like you had in the payment system, where there was a middleman sitting there whose job was to maximize the profits they can make. So you can call them, and I shall call them here for the purpose of this discussion, as parasitic middlemen, right? So the goal was, could in India we build a system for flow of people, flow of money, flow of information, where instead of having parasitic middlemen sitting, we have public utilities that are sitting in its place. Now, that system has turned out, that bet has turned out to be a golden bet. Why is that the case? Because today, as we sit here today, you should know that India will do more than 50% of the world's digital transactions in India alone. And that number is growing. So there are three types of digital transactions. You can divide up India into three Indias. India 1, 100 million families. They are the richest 100 million families of India. India 2, who should have been served by the financial industry, but were not being served in the financial industry. As you know, if you go back to 2004 timeframe, or to 2014 timeframe, only 17% of the adults in India had a bank account. Today, that coverage is almost 100%. So they were not being served even for something as basic as a bank account. And the third is benefits. The third 100 million families, they need the government benefits. So today in India, when it comes to the first 100 million, the best way to measure whether they've gone digital or not is to see whether they pay taxes digitally or not. So I don't know, you all do. And so you should know that India, for tax transactions, India does more than 50% of the world's tax transactions by volume, not by value, of course, but by volume. Okay, so I can skip the slides, or I'll go to them, when needed, because I'm committed to this path of doing it without the slides. But the second is that the second part is that if you look at that Haryana girl that I talked to you about railway tickets, about buying something from the Kirana store, about e-commerce, we do 48% of the world's digital transactions in that area. And in a year or so, we'll overtake 50%. But when it comes to DBT transactions, direct benefits transactions, India does 72% of the world's direct benefit transactions. Again, not by value, but by volume. So now if you look around, people in the world are sitting up and noticing. They're saying, how is this country, which has gone from zero to hero in a matter of few years? And remember, our share of the digital transactions of the world, 50% means that you can take China, if you start from there, you can go to Korea, you can go to all of Middle East, you can go to all of Europe and all of US, and all the transactions that they do are smaller than the transactions that we do, right? So it's a significant milestone that we are talking about. So I want to tell you why this has happened, because the why is important here as we go forward. The why is because we ended up building the right primitives. But not only building the right primitives, but building them in the right way. The right way is that we, instead of putting those parasitic middlemen, we decided to put public utilities in the middle. Now, DST is actively involved in making this come alive for geospatial data as we speak, right? So the data economy of India, we have this AI summit that will take place in February of next year. One of the stories that India will tell to the world that the data economy that India is creating is unique because it has, instead of having those parasitic middlemen, it has public utilities in the middle. Now, those parasitic middlemen are truly parasitic middlemen. If you look at payments, those parasitic middlemen charge 2% for every payment. When we use UPI, how much do you pay? 0. But if it was 2% to be parasitic middlemen in the flow of data, this wouldn't be so bad. Can you guess how much they charge? I'll give you only 3 choices. How many of you think it is 25%? How many of you think it's 50%? How many of you think it's 72%? Right, I see correct answer coming from there. And so therefore, one of the richest companies, these are the trillion-dollar market cap companies, I won't name them, but they charge a lot because they can. And they have such monopoly in the market that you can't displace them. Now, this is not unusual. Back in time, if you wanted to do very early days a mobile payment, they would charge that mobile payment on your telephone bill. And the mobile operators used to charge 70% for making that payment possible. So 70%, 30% are very large amounts. You can't have an innovation economy if you do that. So India has taken an approach to actually change that by putting public utilities in the middle. That system is working. DigiLocker does 21 million transactions a day. A month account aggregator does 15 million transactions. You have new systems that are coming up, including the global geospatial data interface, which is going to completely redefine this data economy as you go forward. So first is that we made this happen. Second is we made this happen with a philosophy that many of you often don't appreciate. I took a flight from Bangalore to come here using DigiYatra. And imagine I bought something in Bangalore airport, paid for UPI, then I used an Uber in Delhi, paid for UPI. Now the reality is our system is so designed that the government does not get access to my travel. They can't go to DigiYatra and ask DigiYatra, give me all the flights that Sharad has taken. That's not possible. There's a privacy-preserving architecture that doesn't allow this. It doesn't allow this not because the government doesn't want to do it, which of course is the case, but the public technology is built in such a way that even if the government wants to do it, it is not possible for it to do it. Similarly, NPCI does not know that I have moved from Bangalore to Delhi because my UPI transactions, that data doesn't go to NPCI. Similarly, when I open a bank account with Aadhaar, the government does not know all my Aadhaar-enabled bank accounts that have been opened up. So we have built, as a country, privacy into the system in a way that no other country has been able to do so far. And this is only one of the 5 important principles that we have. Privacy. We also have techno-legal regulation, public tech, public policy coming together. We have others that I don't have time to talk about because I have only 25 minutes. So therefore, there are many things that stand out about the India system. How many of you here do yoga? Don't be shy. How many of you also practice Yoga Sutra, not just the Yoga Asana? Full benefit of yoga comes only when you do the asana and the Yoga Sutra. Yoga Sutra is the way, the philosophy of life. When that is practiced with asana, then you get the full benefits. So what India has done is actually created these DPI sutras, which the world is turning around and paying attention. So it's not just the manifestations that you see, the DigiYatra, the Aadhaar, the UPI, those are important, of course. But what's behind them, what's beneath them, the principles, I would submit to you, are even more important. So why is this important in the long run? I'll talk about it in a minute. So this, of course, has led to a new body of knowledge. How is technology designed for public tech that is done? India is the epicenter for this in the world. How do you then make it possible for it to be privately provisioned public infrastructure? You know, it took us a long time as a world to understand how to have airports that are privately provisioned public infrastructure, to have roads that are privately provisioned public infrastructure. No country in the world, including the US, had actually thought of having privately provisioned public infrastructure for digital. This is an Indian idea that works at scale. You use UPI for free, but it's privately provisioned public infrastructure. So India is really the thought leader for this, and that has led in a new set of organizations being created which are taking this story forward. Adil, for example, is involved in ONDC here, which is on the picture. But the real story is that we have a DST model. I use that word carefully. I mean it in a good way. We have a DST model for a whole of nation approach. Every country that has progressed in science and technology has to bring research, market, and policy together. That's not new. The way the Koreans do it is different from the way the Japanese do it, which is in turn different from the way the Israelis do it, which is in turn different from the way the Americans do it. But anybody who wants to progress has to bring these three parts together. So this digital revolution has given us an opportunity to stumble, and I would say stumble into a model that allows us to bring these three parts together in a new way. So in 2022, something very interesting happened. At that time, one of the secretaries in the government of India, he challenged all of us to say, hey, this was about inclusion, but can you make this happen for strategic autonomy? Because we need strategic autonomy in defense. We need it in telecom. We can't rely on foreign telecom equipment, especially Chinese telecom equipment, right? And we need that in electronics. So the question is, what would be that whole of nation approach for these three areas? So that has started taking shape. And the success story that we have is actually related to telecom. In telecom, no matter which operator you have, the people who supply equipment to them is hence Huawei, Ericsson, Nokia, and Samsung. Now there is a new company. That new company is Tejas Networks. It's owned by Tatas, but it's Tejas Networks. But Tejas Networks came from an ecosystem, a Darwinian ecosystem that was created, in which originally there were 16 companies, of which 3 have done very well. In Tejas is, of course, the most successful. But remaining 13 haven't done very well, and maybe 1 or 2 of them will go on to be successful. But the fact of the matter is 10 will fail. This is not unusual. This is not a bad thing. This is a good thing, because you want to pick national winners from such a Darwinian ecosystem that is there. Now, whenever we have picked national winners by appointing them as national winners, it hasn't worked. It used to work. ISRO, BARC, it did work. But after that, it stopped working. CDOT was set up 31 months before Huawei was set up. And the gap between the two is absolutely stark. So we need a new method of bringing our science and technology economy to the surface and bringing researchers, market players, and others to the table. Now, silently, quietly, this is happening. And I'm very happy to, I have a quote from somebody who is on our dais here. You know, and many people here on the dais and outside are quietly working together to bring this to life. And a whole playbook is starting to emerge. But this playbook is to implement a game plan. What is the measure of a game plan? Measure of a game plan is, if there are 5 leaders in that industry, one of them will be an Indian company. If there are 5 leaders in telecom equipment, one of them will be an Indian company. If there are 5 leaders in AI, one of them will be an Indian company. That requires a game plan. That requires a playbook. And that requires us to, again, do it in a way that brings researchers, policymakers, and market together in a way that we have not done in the past. We have to make a new beginning. One of those new beginnings is to focus, to supplement the ANRF work, to also do pre-commercial. because the whole value chain involves basic research, pre-commercial research, and commercial research. We have to motivate our market. Now today, there are 5 companies in India who make $10 billion and more profit a year. There's Reliance, there is Adani, there is Tata's, there is SBI Bank, and there is HDFC Bank. $10 billion a year is a lot of money, profit. We have to convince them to spend money on R&D. But they will spend money on R&D to commercialize R&D. For that, you have to give them pre-commercial R&D. Pre-commercial R&D requires, your foundational R&D to be there. So this chain has to be put together along with everything else that we talked about and make India, therefore, a Viksit Bharat. Get strategic autonomy in areas that we care about. Become a product nation as we move forward. It's going to be very hard. I won't lie to you. It's going to be very, very hard. You know why will it be very hard? Because unlike other countries, which I mentioned to you, Korea, Japan, Israel, I would say even China, the West supported their rise. They wanted them to become technology superpowers. Now, the West has said that we made a mistake with China. We can't afford to make the same mistake with India. That's the reality. They may not say this to us directly, but that is actually what they feel inside. China doesn't want us to become big. So our rise will be a resisted rise. And therefore, we have to acknowledge that we must do this in a way that is not dependent on the goodwill of others, but is dependent on our own capacity to do it right the first time. And I would suggest to you that this is always been the case with India Stack things that we're talking about. Do you think the 4 big payment systems of the world, Alipay, WeChat Pay, Visa, MasterCard, wanted UPI to succeed? No. They resisted it in every possible way that is there. Do you think, the world wanted India to be a COVID vaccine power? No. They would have loved a situation if India was not a power in the COVID vaccines. So we know that we will deal with this. We know we will have valleys of death. We will know people will resist us, but we can make it happen. I'm sharing with you the journey line of UPI alone, which has had 3 valleys of death before it became successful. So I want to conclude with just one statement. It's going to be tough, but we can do it. And in this transition that we are talking about, the biggest piece is going to be research. Because if the foundational research is not there, then the markets cannot actually spend money to commercialize. Government cannot make the policy to actually help those Indian companies succeed in the market. So it starts with research. But we must do it with a new mind, a new mindset, with a new mission, with new focus, new energy, and new sense of purpose. And I think that is coming already. DST in the last recent years is reflecting that. And I think in the future will be the most powerful engine of India becoming a Viksit Bharat. So a lot is resting on your shoulders. I hope you will rise to that occasion. Thank you so much.
Thank you, sir, for a very insightful and a comprehensive keynote address. We now move to the Foundation Day lecture by Dr. Adil Zainul Bhai, Chairperson, Capacity Building Commission. Dr. Zainul Bhai's contribution to institutional transformation and digital governance are widely recognized. With over 3 decades at McKinsey & Company, and then as the chairman of the Quality Council of India, Dr. Zainul Bhai's current leadership at the Capacity Building Commission focuses on enhancing civil servant training and performance to improve citizen services. I would now like to invite Dr. Adil Zainul Bhai for the Foundation Day lecture. Over to you, sir.
Dr. Jitendra Singh, Dr. Sood, Professor Karandikar, Sharad. First of all, it's amazing to stand here. I should own up to a couple of things first, especially in an audience of DST. I'm not a doctor. I'm sitting on this table with all these doctors, and it's very, it's very frightening. It is only, the only other time I felt like this is when I went back to IIT after 25 years, and I saw 50 professors sitting in the front listening to me when I was their student. So excuse me if I feel a little nervous. Doctor, doctor, and doctor. So Sharad, thank you very much for setting the stage for this. I want to start out with a question for everyone. You don't have to say the answer, okay? But I would just want you to think about the question. And Professor Karandikar, you can't. I gave you the answer. So you can't say anything. The best biotech department in the world today is at MIT. Of course, if you're a Stanford graduate, you might argue, but basically it is, MIT is one of the best biotech scientific departments in the world. Their professors have done quite a lot of things, which I'll talk about. So I want you to think about the following question. What is the net worth of an average MIT professor in biotech at MIT today? Not what they earn a year, what is their net worth? I'll talk about it when I come to my talk, but I want you to think about it for a second, okay? And then I will ask you, what is the net worth of Professor Karandikar? Okay, so I don't know, did you start some companies or something? You have, so maybe, okay, so I take it back. Dr. Anil Sood, okay? I mean Ajay Sood, sorry, Dr. Ajay Sood, right? So I want you to think about that because there's a point I want to make in this, but I want you to think about it while we come to this. So I want to build on Sharad's point, which is our aspirations for Viksit Bharat are very high, as Minister has said, and as Professor Karandikar has said. We want to be a scientific superpower in many areas. To get there, what does it take to get there, and what do we need to do to get there? So what I want to talk about here is the fact that it is not enough to do great science. It's not enough to invent a few things. Ultimately, it has to come to the market and change people. If you look at some of the Chinese companies that have become very successful, Huawei is now worth more than any other telecom gear manufacturer in the world. It's only 35 years old, I think you said, right? Its market cap, I don't even want to think about. But until you make it successful in the marketplace, and until that linkage between basic research, our universities, our labs, and our companies works, somebody else benefits from that research, not us. So I want to talk a little bit about how some of these clusters and some of these successes came to be, and what does it say for us. And I'm very glad that I have an opportunity to talk to DST, because in a sense, your broader mission is not just an individual science project. It is not just dishing out funds, of which you have a lot. Thank you. That's great. But how does that actually get to the market and affect people's lives and create companies of stature, whether they're government-owned or private sector-owned or not? Until you do the full chain, it is just a very interesting idea. So DST, in a sense, you have the opportunity to do this. So that's what I wanted to talk about. So I'll start out by, oh, here it is. Let's see if it works. I'm going to skip a few slides just for the fun of it. Does it work? Can I move? Just go to the third or fourth slide. See if this works. And I'll tell you. Next. 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 Next, 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 next. Okay, I'm just going backwards. It's more fun to mix things up. How many of you recognize this person? His name is there, but how many of you have heard of him? So all these people from DBT have heard of him, and you have, of course. So for many of you have not heard of him, and I hope, and I wish you had, and I hope you will look him up. Okay, Dr. Langer invented some of the fundamental technologies that are at the heart of the genomic revolution today. Okay? He was involved in, he probably has something like 50 patents. I think he has started, at last count, something like 30 or 40 companies. And he's still a full-time teaching professor. Every PhD student of his would want to start a company with him based on some research that they did. And in fact, many of them have. Most of you, since we talked about COVID, have heard of Moderna. Moderna's RNA technology, the scientific basis for it was invented by him. He invested in Moderna when the people at Moderna were students at MIT. And he owned a small proportion of Moderna. He started Kala Pharmaceuticals, in vivo therapeutics, and a whole series of others. And so now I'll come to my question for you to think about. He is worth a lot more than the average MIT professor. So I want you to think in your mind, what is he worth? What is his net worth? He's in his 70s and 80s. I don't think he cares about money. He cares about solving problems. He cares about coming up with suggestions, coming up with new therapies for people to solve things, right? Robert Langer is worth over $1 billion. Okay? That is what he has created. And some people would say that he has created 50 to 100 companies, even if he doesn't own ownership stakes in them. He owns ownership stakes in about 20 or 30. Okay? Anyone would give him any amount of ownership that he wants if he would help them succeed, because if he is backing you, it means the technology is sound and that you will have a great chance of succeeding. Otherwise, he would not back you. Now, I want you to think about some of our best scientists who potentially have done as path-breaking work as he did. You know, we did that in COVID, and we did that in some of our labs. And where would you put up a photograph like this that said that they have created that kind of market value for the country? Okay. So we have to make that step. Some of it is a set of policies that we have to change so that we can have people like this be successful in India. And I'm very hopeful that 10 years from now, if I'm ever allowed to come back and speak to you, or you might say, this is a terrible idea, we don't want to hear from him again, that we will in India have people who are this successful. Go back one slide now. Okay. No, yeah, that's okay. One more. So I now want to talk about not just Dr. Langer, but I want to talk for a minute about the MIT ecosystem in biotech. Okay? Of course, they have great labs, and of course, they spend a lot of money. Their budget is probably the equivalent of many of our labs combined, maybe as big as all the CSIR labs combined, who knows. But what is very interesting is not only do they have a lot of patents, but the number of startup companies that have come out of the MIT ecosystem is phenomenal. Everybody fights to get into their undergraduate and PhD program because of the number of companies and the successes that have occurred after this. I won't even talk about this in some detail, but 300 plus patents that have been filed. The number of awards that they've got is huge. The licensing revenue that MIT itself gets, forget about the professor, every year is huge from all of this. It has created this giant ecosystem that they have built over many, many years. Now, I want to ask another question. How many of you have been to Boston? You've been. You've been to Boston. Okay. If you've been to Boston, you've been around the MIT campus, or you've been to a place called Kendall Square, which is next to it. Something like 15% of all biotech companies in the world are in 5 buildings in Kendall Square that are right next to the MIT campus. And the closer you are to the MIT campus, the more valuable that real estate is in this, right? So it is amazing how well that ecosystem has flourished and how the design of the academic, business, research complexes that allows this to happen. I'm very happy that IIT Madras, IIT Bombay, IIT Delhi have started creating research parks. And I have to say that IIT Madras has done a fantastic job. All of you have heard about it. The MIT Research Park is 150 times as big. Okay, so we have had great successes, but if we want to emerge as a scientific leader, we have to think much more broadly about what we should do, as Sharad said, right? And I think DST has to be in a position to drive this. Because if you and the chief scientific advisor can't create the policies to drive this, it will never happen. Obviously, we are encouraging it. I'm involved with IIT Bombay's research park. I'm chairman of the board of IIT Ropar. We are putting up a research park and getting a lot of people to help run it. But I think we have to scale this up a lot if we want to get to this. And if we want to be the leaders in any technology, this is what it takes to get there. Okay. I will now do one more example, and then we'll talk about the answers to my questions. Please skip 2-3 pages. I'll tell you till when. Keep going. Yep, stop, go back. Okay. How many of you visited Stanford? This front row has visited everything. You visited Stanford, right? If I had not put the names of these people, would you recognize them? You would, because you're in computer science, right? But these three professors, especially David Cheriton, Christopher Wray, and Fifi, and Fifi's name you might have heard recently because she was a professor there for 20, 30 years, did a lot of work in AI for vision recognition, in vision. And she worked there for quite a long time, has made a reasonable living as a professor, and she's just got funded for $1 billion startup. Right? First company that she's starting got $1 billion of funding with zero revenue. Right? The valuation, in that, right? So David Cheriton has started, a whole series of companies. But actually, Christopher Wray was one of the early investors in Google. He was also the investor in Cisco Systems and a whole series of other companies. David Cheriton owned a piece of Arista Networks and 30 other companies since then. The link between Silicon Valley and Stanford computer science is incredible. The number of companies that have come out of Stanford is, in fact, basically the valley lives on Stanford and Berkeley, is phenomenal. The professors have done their best work over there, and they have gotten the university. I think Stanford gets $100 million in royalties from the companies that started from Stanford. And these professors have been able to do both the cutting-edge research as well as converting it into successes in the marketplace. So I'll go back and say these are two great examples. I am very, very hopeful that in a global forum, if I had to speak about this a few years from now, that I would be able to add the third and fourth example from India. There are examples in China, there are examples in Korea, but I would love to be able to add an example in China. And as Chief Principal Scientific Advisor, as Minister of Science and Technology, and as Secretary of DST, I hope that you will take this on as your challenge to make us in the same league as, make our clusters in the same league as this. So, now I'll end by trying to answer the question that I first asked you. What is the net worth of an average MIT biotech professor? Karandikar is saying 5 billion kya hai? Kuch nahi hai. Actually, to be honest, it's very difficult to calculate, but my calculation is 100 million. Okay? But that's not, I'm only saying this for shock value, okay? What is really important is that they took the technologies that they worked on and took it all the way down and created something that is helping save the lives of millions of people, and they took it all the way down. And they continue to do that. And I think we have the potential to do it if we want to be leaders in the technologies that we talked about going forward. I hope we can create complexes like this. Thank you very much.
Thank you, sir, for such an inspiring and engaging lecture. Your presence and valuable contribution have made the occasion truly memorable. Now let's move forward and welcome our guest of honor, Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India. Professor Sood is a renowned physicist, a distinguished honorary professor at the Indian Institute of Science, Bengaluru. Professor Sood has received several prestigious awards, including the Padma Shri and the Shanti Swarup Bhatnagar Prize and was elected Fellow of the Royal Society in 2015. Recently, Professor Sood has been elected as a member of the American Academy of Arts and Science. I now request Professor Ajay Kumar Sood to kindly address the gathering.
It is indeed a privilege to be among the dignitaries on the dais, our respected Honorable Minister Dr. Jitendra Singh ji, Dr. Adil Janul Bhai, Dr. Sharad Sharma, Abhay Karandikar, and all the distinguished dignitaries of the dais. So first of all, my congratulations to DST on its 55th Foundation Day, marking over 5 decades of our nation's pursuit of excellence in science, technology, and innovation, with DST playing a very pivotal role in shaping country's scientific landscape. And Abhay elaborated some of that in his opening remarks. And on a personal front, I can say that my scientific career over the last almost 52 years, out of which 35 years in IISc, when I joined after leaving DAE, has been built entirely, mostly on DST funding. So this is something, and I couldn't have done what I was able to do, even with the funding which some of you may call modest as compared to international benchmarks. But I think this is where DST took risks. They funded the people who had ideas, who had vision, and this is what actually DST stands for. Now, in more recent years, our thinking is also evolving, as we heard in the last 1 hour. So we need to see how science, technology, and innovation can play a pivotal role in strengthening our economy and enhancing the quality of life of our citizens. This is something we must address through S&T intervention. And we heard already the India's success stories in digital economy, which Sharadji said in his spirited voice. He is the founder of the iSpirit, but that is also reflected in the way he articulated. So we all know that there is a lot of journey in this transformation. And I thought before I dwell in this, I would like to honor the words and wisdom of Dr. K. Kasturirangan, who passed away recently and who contributed immensely to our science and technology ecosystem. He, of course, brain behind NEP, so ISRO successful launches and so many things. This is not the time to elaborate, but I'll just read his message, which really reflects, I quote, "Science and innovation are the twin engines of growth, and India must harness them with clarity and commitment to stay ahead in the global race," unquote. So I thought very well said as we make this transformation when we take science and technology to the society in a bigger way. Now, if you look at, there are many things we need to do. We need to see what are the key challenges in this journey. So I'll just say a few things which you already know, but I thought on an occasion like this, we can remind ourselves to strengthen this alignment of our research ecosystem with the industries, with the startups, with the national priorities, so that we can be a product nation. We should look at the following. Number one, research outcomes from various government departments. It's not only DST, it's not only DBT, MIT, DOT, ICAR, enormous number. And I have learned so much after coming to Delhi in the last 3 years. So much is happening in so many departments, and I still feel it is happening in silos. In spite of the repeated call from our Honorable Prime Minister to break the silos, those silos are getting addressed, but we still have a long way to go. So we must look at coordination to integrate and encourage all these what is happening, but also encourage private sector participation and ensure market readiness of innovation. Number two, an upstream research ecosystem where private sector challenges guide academia efforts to foster collaborative problem solving that needs to be encouraged. And third, joint R&D centers where active industry participation from early innovation stages to enhance synergy between academia and industry should be enabled in a much more rigorous manner. And of course, incentives which was mentioned, such as industry-led research parks. Some examples are here. They are in the academic sector, but we have to see more industry-led research parks and so many other features which can come in when we look at corporate fellowships for PhD scholars and so on, so that there is a strong ties between research and business. And all these things, we of course will need some intervention, some thinking on intellectual property concerns, unclear commercialization pathways, how do we create market for our products which originate from India, and how do we make sure that all these deep tech startups which come up, which are really only 10 to 12% in a large startup number of almost 1.6 lakhs, we have only 10% of them deep tech. How do we really enable them? We will need some interventions, some policy interventions. Some of it we have worked on a policy document, and we like creating funds of funds, creating processes where the inventors in academic sector, they are enabled to do going beyond from their lab to opening industries, opening startups and so on. So a lot of things need to be done if we need to enhance this. And there is another thing in deep tech issues, because deep tech means it is based on high-end science and technology, and it cannot be just perturbative, just not incremental. And for that, you need to see that the research facilities are available to private sector, they are available to startups, they are available to tier 2 and tier 3 institutions, they are available to all researchers and are really not tied to only few principal investigators which DST funds, they are made available. So keeping that in mind, there is a very, very powerful program which is evolving. It's called iSTEM, started by our office and inaugurated by Honorable Prime Minister in 2020, which lists all the instruments above a certain value on this platform. And this is available to researchers, startups, and industry outside. And that number is increasing day by day. And all the new funding which will come from DST, ANRF, and so on, it is not a choice, but it's a must that those facilities will be put on the portal. And recently, DST has come with another innovative idea, how to support the maintenance of these equipments even beyond the research, the project period. So all this I am mentioning because this is a time when we need to see what are the new steps we need to take to really have this collaboration between academia, research labs, industry, government, all seamless so that we can really amplify the outcome. So in this, we have new initiatives. Of course, DST continues to innovate and have new programs. Now we have ANRF, which is launched last year, and we have now the new CEO, and the new programs are being rolled out. PAIR has been rolled out already, EV mission has been rolled out, and so many other things are happening as we speak. And this is something which all of you need to participate to see how we can really depend, not depend, but rather encourage all these systems and participate in a proactive manner. And another one which will happen probably sooner than later is the 1 lakh crore corpus, which has been announced by Government of India as a loan for R&D in private sector. I think it is absolutely a disruptive idea and a path-breaking step which our government has taken. It has never happened so far. 1 lakh crore is already granted, and 20,000 crore is already there in this year's budget. And this is what inflated DST budget, which it make 28,000 crore, but actually 20,000 is the loan which DST has to guard. And but this is a really path breaking. This is what will encourage R&D in private sector. It is what government says, it means it, and it is enabling it. And this is where we need to see how it can be done with this private sector participation. I think it's a wonderful opportunity where R&D in private sector, R&D in academic institutes, R&D in national labs, they are all synergized to really deliver the outcome. So I think I'll close my remarks by again remembering what I said in a recently held Yugam conclave, that India stands at a pivotal moment in its scientific journey, determined to be a leader in frontier technologies and not a follower. From breakthroughs in quantum and AI to advancement in space exploration and digital innovation, the foundation we have built so far in a robust and uniquely manner is rooted in a model that combines government-led platforms, private sector participation, and sound techno-legal framework. And this is extremely exemplified with what Sharad said, and this is what we need to see. How do we really do it in other sectors, including AI and including quantum and so on? So all these things need to be really put together to see that we have sustained effort and accelerated effort in our path to really making S&T as a part of our strategic autonomy, technological sovereignty, and the economic wellness of our entire citizens. So in this, I am very, very sure DST will continue to play a pivotal role along with other funding mechanisms, other frameworks like ANRF, DBT, other agencies. I think we need to synergize all of this so that we have minimal overlap and maximum results. And once again, I congratulate the entire DST fraternity for really doing this wonderful job. You are carrying the torch of innovation for the last 55 years. Continue to do that and let it shine brighter. Thank you very much.
Thank you, sir, for your most insightful and inspiring words for the entire scientific fraternity of the Department of Science and Technology present here. Now, with immense pleasure and deep gratitude, I would like to invite our chief guest for the 55th Foundation Day of DST, Dr. Jitendra Singh, Honorable Minister, to deliver the Foundation Day address and for sharing his vision for India's future in science and technology.
On the dais, Principal Scientific Advisor to the Government of India, Professor Ajay Sood, Secretary, Department of Science and Technology, Professor Abhay, Dr. Adil Bhai, Dr. Sharad Sharma. I can see directors of various autonomous institutes sitting in the audience, in this galaxy of gathering. All of us come here to celebrate the 55th anniversary of the founding of DST. I can see some illustrious people. Our former secretary, professor, of course, I should say, Padam Shri Ashutosh Sharma, and our latest entrant into the family, Dr. Shiv Kumar Kalyaraman, who also happens to be the founder CEO of the National Research Foundation, which speaker after speaker had been mentioning before me. Now, I wish I was wearing the same hat or in the same shoes as the other speakers, because they had the privilege of sticking to the theme of their choice. So as a chief guest and as a minister, I have to speak partly as a minister, partly as a member of scientific fraternity, and make sure that I'm scientifically correct and also politically correct. So I'll try to perform that as best as possible in the next couple of minutes. Of course, at the outset, when we celebrate the 55th Foundation Day, I think what is also important to realize is that the founding of the Department of Science and Technology and its journey over the years has also been essentially a journey which is a reflection of the march of science, technology in this country as a whole, and also the ministry as such. Because I don't know how many of us in this room would recall that at the time of independence, we didn't have a ministry at all, and least of all the department. At that time, science and technology was part of the industry ministry, and therefore the first ever industry ministry of India, Dr. Sama Prasad Mukherjee, also happened to be the minister looking after science and technology, and by virtue of that also the first vice president of CSIR. And all that the government sector science had was CSIR, because it had just been founded at the time of independence, and also some of the labs which were incorporated had been there even before independence. And then gradually, when things started evolving, we had, of course, Space Department, which was not essentially a part of the ministry, so also the Department of Atomic Energy, not essentially or officially a part of this ministry, but then gradually, as we moved on, so we had the Department of Science and Technology, and then DBT, etc., and so on and so forth. So I think this is also, in a way, tracking the journey of post-independence India. And therefore, it's also time to acknowledge the contribution made by all the colleagues and not only the members of the scientific fraternity, even the administrators who have helped in this progressive growth of the department and the science. And as Professor Sood was saying, that he has been a beneficiary because he was also the recipient of much of funding done by the Department of Science and Technology. So I think that also has been a contribution. But as a minister, my experience is that most of those who come to me, come only looking for funding. But I have a good excuse to direct them to Abhay, and I tell them first go and make a presentation to Abhay, then come back to me, because they feel the ministers don't have much of an idea of the scientific presentation. So it will be easy to motivate a political functionary to agree to funding. So I wish Professor Sood doesn't talk much about it in the public forum, because that will create problems for Abhay and me. But nevertheless, that's a great acknowledgement. Thank you, Professor Sood. And at the same time, I think one also needs to acknowledge that in the last 10, 11 years, as I also said in that innovation conclave the other day in Bharat Mandapam, that there has been a very visible push And I don't say so because I'm part of the government, because half of my time is spent outside in the other government circles, and mostly in the medical fraternity, because I have been in this business of seminars, conferences, and all this thing, the research domain, as a teacher of medicine for many long decades. It is now being realized even outside the government circle, because we didn't have this kind of an enabling milieu before 2014, which is happening now. We have a political dispensation which is open to inputs, which is open to listen to you and give you time enough with patience from the highest quarters, from the Prime Minister himself. Otherwise, you won't have. I remember when we got this biotechnology policy passed, with a series of presentations made by Rajesh Gokhale directly to the Prime Minister. So each time he would come back and says, I'm afraid I've not been able to go. The last two presentations we were together. And we went on, and finally we could convince, and Prime Minister was kind enough, very open enough, that when we said that this may not appear to be very relevant today, but we at least would have initiated ourselves into this domain instead of waiting for others to initiate. And this is precisely how the Honorable Prime Minister explained it to the other cabinet colleagues. So at least we have that kind of a political patronage which was not available. And as the Prime Minister himself said in that day on the Bharat Mandapam program, that the GERD has gone up more than double, from 60,196 crore to 1,27,038 crore. And Professor Sood was mentioning the DST budget, which of course went up from 2,777 crore to 28,509 crore. But that has been also the case in all the other departments of science as well. And of course, the National Research Foundation. In fact, the budget elevation has happened in every stream of science. Even space also is more than 138% increase. And mind you, all this is a part of the pool, which is much larger now with the entrance of the private sector in a big way, and also the National Research Foundation coming in a big way. So I think what is now important, as Sharad was mentioning, I think one important change, more than that, which is not often talked about, is the change in mindset, which has not happened not only at the level of the government, of course, thanks to the Honorable Prime Minister, because he has sensitized others also in the government, but outside the government. Now, he was talking in terms of digital transaction. Many of us who belong to my generation and who come from the similar background as I do, which is more of a rural rather than urban, we had never seen a bank in our boyhood days. And in the entire locality, the extended locality, we had one gentleman, I think he was known as Mr. Khosla because the name is so much etched in my boyhood memory, who was like an iconic figure, because he was working as a manager in one of the banks. So Manager Sahab was a cult figure, some out-of-world figure. So none of the people living around had a bank account. They had hardly visited a bank. They thought bank was something which was meant for people from the other world. And a manager was also sent from the other world to look after all that. So this has been, if you actually try to look into what Sharad was trying to bring home, has been a remarkable turnaround, 360 degree. And today, and as all of us belonging to the fraternity of science have been taught not to speak without evidence, I think the easiest evidence, you just pick up a telephone right now and ask some of a semi-literate person on the other side, कि आप ज़रा telephone number मेरा note करिए. And more often than that, I bet he would say, sir, मुझे WhatsApp कर देंगे? You just try it after this, when you walk out of the room. So that tremendous change of mindset is rather digitalization of mind which has happened, which is not as often talked about. And this is indeed an upcoming area of research also. A few years back, the Nobel Prize for Economics was won by somebody who had written a work on behavioral economics. So this behavioral science, this digital temperament which has happened is actually motivating the other things also to happen. And this has also reinforced the aspiration in the common man and also reinforced the self-confidence. Look here, I can also have it. I can also have a bank account. I can also be one like the others. And that rise of aspiration is visible everywhere. Like I was saying on the other day, in the Civil Services Day, I said, gone are the days when you had civil services list only including people from maybe Andhra, Tamil Nadu, Kerala, or Bihar. Now you have toppers from Amritsar. And that's been so. We had a second topper just a few years back. You have toppers from Haryana, some of the states which never occurred in the civil services. So this has been a part of, because when we evolve as a nation, we have to evolve as a whole. So it is not possible that you have one Professor Ajay Sood, taking up on himself and the rest not getting involved. So I'm glad that there has been a motivation enough. And of course, there's also realization, as Professor Sood rightly mentioned, that if we have to move on, and in fact, I said that in the conclave also, since the Prime Minister was there, I said that there is a realization कि अगर भारत को आगे बढ़ना है, तो वो विज्ञान और नवाचार के रास्ते से ही हो करके गुजरेगा. And some of the old, maybe conceived notions or misconceptions or also skepticism is gone off. As Adil was mentioning, research parks, and of course, IIT Madras has set an example. In fact, I was telling Dr. Jhunjhunwala, I said, you send me a note, I want to circulate it on the social media. But I would rather, in fact, go one step ahead. Why only industry-led research? Why not industry-determined research? So if you have to think in the terms of sustainable research, sustainable startups, you have to give industry a free hand and ask them to do the market mapping. Let them tell what they want us to innovate for them, so that we have the commercial backup also. And the industry partnership or the private partnership has not to be only in the terms of knowledge sharing. At least in the Indian context, it has to be the financial sharing. And I think rather Adil I'm not sure how much you would appreciate, because you've come from a land where knowledge partnership is a commonly used phrase, but in India it doesn't hold much of a meaning, because here to gyan muft mein bikta hai. You sit in a train compartment, everybody will start sharing knowledge with you. And if you tell an industry that they are knowledge partners, they think they have made a fool of you. And I'm glad we have successfully started that. Others also now do that. We are telling you, this Technology Development Board is there, with part of the DST. And I keep insisting, if you invest 50%, make the other party invest 50 or 60%. Because when a private sector or a company invests even 10 rupees, the investor will make sure that 10 rupees bhi wapas vasool ho. Because we have to also take into context, when we talk of Indian ethos, as you're trying to do in Arab, this is also part of Indian ethos. Good or bad is a separate thing. That is a separate subject of research. So unless it pinches the industry, they would not sustain. So you need to have, it's easy to start a startup, difficult to sustain it. And, but of course, what is important is that we have started moving in that course. As Adil was saying, that 10 years from now, when he's on a global platform, he wishes that he would have the opportunity to also include India in one of the instances. And yes, we very hopefully so, we're optimistic, because now at least we are in that direction. As I said the other day also, I said if you have to be a global player, you have to follow global parameters, you have to meet the global benchmarks, and therefore also global strategies. We didn't know that. Now, as the famous English adage goes, the eye see what the mind knows. The mind didn't know. First time we have opened up. And the mind didn't know, and the mind also didn't know that it didn't know. Now, we was talking about biotechnology. It's a good subject of biotechnology. Rajesh is having a bad cough. He's not here. There are two sets of people. One who don't know, the other who don't know that they don't know. So we had a mind which didn't know that it didn't know. And therefore we were we were living in that bliss of ignorance. Now we know that we didn't know, and we are trying to know what is it. We are trying to know what are the success stories or the success strategies followed by MIT. I'm glad to see so many of our startups actually now entering into collaborations there. And of course, as was being mentioned, I think, usually because I don't carry the talking points given by the secretary, so sorry, Abhay, but I try to respond to what has been said by the earlier speakers. As I think was mentioned by Sharad and also Adil to a certain extent, that we as a global player also would have to ensure, and we have already started making a difference in the geopolitical scenario of the world. I think Adil was saying. Of course, nobody would like you to be a successful player, but that precisely is our benchmark. At least in one of the domains that I try to perform, that is the public life, the more you are envied, the more is the indication that you are on a successful path. And as Oscar Wilde once wrote, Adil, when I am no more, I hope it would be said of me, his sins were scarlet, but his books were red. So nobody will like India moving on in strides. But the very fact they would think about us or have started thinking about us, have started discussing us, means that we are now on the right course. But till a few years back, nobody knew about us. And they had all sort of strange stories about snake charmers and whatnot. And therefore, I think I have to also compliment, and that the results are now showing. In the last 10 years, of course, you come from fragile 5 to top 5. Our startup has gone up to rank 3. Our global innovation index from 81 to 39. We are ranked 6 in patent filing. But what is heartening is that out of 64,480 patents registered right now, nearly 56% are Indian residents. Why I try to emphasize this? Because nobody actually realizes it. Earlier on, the common refrain was, "Arey saab kar bhi liya to kya hua? वो तो गया अमेरिका तब हुआ, हरगोविंद खुराना बाहर गया तो हुआ, चंद्रशेखर बाहर गया तो हुआ." Now these 56% बाहर नहीं गए. They were born here, groomed here, educated here, worked here, and have made a success without. So that means India today also has succeeded in creating that kind of a favorable ecosystem and an infrastructure which is not to be sought after outside India. And I think the whole ecosystem will also include the NEP 2020, which you were associated with to an extent. Because much of the silent or unrealized harm to the entire cause was being done by an erroneous education policy. About 8 years back, I was with the Vice Chancellor of the Cambridge University, because he happened to be a very senior teacher of microbiology. So being from the medical fraternity, he was fond of some of us. So he told me, "Doc, I have to compliment you. My university would close, my PhD would close if I didn't have boys and girls from India." And when we walked out, I told one of my colleagues, I said, "Was it a compliment?" He said, "What is that?" I said, "Because from Indian boys and girls come here looking for a trophy, not for a PhD. He's not getting local boys and girls because they would come here only if they actually want to do it." So we have a person doing PhD, and I know many of my own contemporaries, I don't want to name them, they made a name for themselves. Even from your IIT, Delhi, some of them were also decorated in that Golden Jubilee. Done PhD in biotechnology from Cambridge, from Oxford, come back and become MD in an IT company or a computer company. But both win-win. The company head proudly says in his morning walk कि मैंने Cambridge का PhD रख दिया manager. And nobody knows कि किस चीज़ का PhD है. And the spouse is happy that big package is there, pay packet. So that mindset has, I think, NEP, because it will take 3 generations. They कहते हैं संस्कार बदलने में 3 पीढ़ियाँ लगती हैं. NEP will change that mindset also, because it gives you the opportunity to juggle with your subjects, to change the subjects. It's going to be a learning not only for the student, also for the teacher. One of the earliest universities to adopt this was some of the central university located in south in Tamil Nadu. So I asked one of the ladies there in one of the Christian colleges, I said, how does it feel? She said, more than students, I enjoy it. Because I teach literature and find people from biochemistry coming in. Because they come out of aptitude. So their learning urge is much more. They are not there by compulsion. They are not reading a subject chosen by their parents by default, and they got stuck into that because they can't change it. Because class 12, they possibly went for biosciences to become doctors, could not, but then the subject changes them. So when the learning happens, that also will be a kind of a creative innovation to nurture this part of it. Like Francis Bacon once said, the greatest harm to the cause of literature is done by the teachers of literature. So here teaching is not happening as a dogmatic exercise. It's happening in a two-way, mutually acceptable. And therefore, I also, before I conclude, I think Abhay would then complain that I have not referred to some of the good work done by him. So as I said, I have to also not to forget that I have a chief guest who's expected to light the lamp and say all the good things. So the good things I have to say about him, that in the last few years, we have had several mission mode programs, the National Supercomputing Mission, and these are all forward-looking, so we are not behind other countries. National Mission on Interdisciplinary Cyber-Physical Systems Law in 2018, National Quantum Mission, of course, very recently, and some of the new experiments like iSTEM, which Professor Sood was referring, National Geospatial Policy is a new concept. In fact, the entire face of the Survey of India has been changed in this term of, because it had been conveniently forgotten, the Survey of India is also part of the DST. And the benefit of that was being taken by the officers there. They're living in a big farmhouse. It's all been changed. In fact, now we are going to have officers from the Indian engineering services rather than security forces, because that is what is the requirement now. And National Research Foundation, I think, as I said that day, that I have the confidence that this is a better model of the similar foundations elsewhere, because it combines the traditional knowledge with the cutting-edge technology. And I was just now asking Adil, have you met Dr. Shivakumar? He said partly met, partly not met. So he said this is a phone acquaintance, but soon I'm glad that he would also be contributing to make a success story out of this. And of course, the private participation, as I said, hardly need to reiterate the synergy between research, academia, innovation, and industry. And as I said, I would rather go one step ahead, let industry participate in a big way. And for that also, the change of mindset is required, in the sense that even in the government sector, now, thankfully, in the last few years, it's no longer. There was skepticism, both inside the government, outside the government. So government thought of every industry man as a kind of a fleecer, or a black marketeer, or a tax evader. And the private sector thought of every secretary as a bribe taker, as a nepotism practitioner. And that skepticism is now gone. A few years back, I had the audacity to tell a mixed audience, I said, look here, when you board a bus, you don't know who's sitting next to you, a devil or a saint. And suddenly the bus breaks down and driver says, now only I'll be the person in the steering, all of you get down and push the bus. And what do? You don't ask a devil, कि भाई तुम जोर नहीं लगाना, you're a devil. You say, नहीं तू भी लगा जोर. So if you have to reach the destination, everybody has to contribute his or her might. And we have to learn to adjust with each other, or also learn from each other goods and bads. So, and luckily this government is open to that. I think no better evidence than that we could have the Prime Minister accept opening up nuclear sector to private players. I remember very vividly, till a few years back, one of the directors in one of our plants in Tamil Nadu, he had his family visiting the plant, and out of, when they were leaving, out of just fancy, the children took a photograph standing besides the gate and the display of that name. And next day there was an explanation call. So much of secrecy was being observed for, for what reason. Leave alone the private secretary, even the families of the scientists working there were not permitted without due permissions. So there's a huge change now, and thankfully the Prime Minister has, and of course we have done that in space, and the results are there for anybody to see. In space is a success story of an interface between private and public sector. We have tried to recreate it in the biotechnology for a BIRAC. Only yesterday I and Abhay were discussing that we would involve Mr. Pathak also to evolve more of a, in-space-like model rather, and make it more industry-friendly and industry-welcoming. And of course, as Professor Sood was saying, the NRF in his 1 year has already launched the mission for electric vehicle, automobile, and also the pair experiment, the partnership for accelerated innovation and research, in fact, which was one of the motivations which led to the formation of NRF, because many of the state universities will say that they are the victims of the mismatch in funding. And in addition, because as we say, we have not to forget the Indian conditions, we have dedicated now programs, also credit goes to Abhay and his team, for women promotion science, the WISE program, the SHE program, I don't know how many of them, the tribal hubs. So also concentrating on certain sections. And now finally also, very recently, the Web Hub is another good program, encouraging the outsiders to come back. Because there are not many now who are ready to come back. As I said, not only that we are being discussed, there are also those who want to come back, because when they went, they thought it was not there what they were looking for, but now they find everything is here. But I keep visiting one or two colleges or institutions every week. I have to be somewhere or the other as a part of my academic. So what I try to appeal, and I wish everybody of us would also bear me out, is that those who go out for certain reasons should be advised to plan how many years they are going, 4 years, 5 years, with what definite objective, so that the timeline of the return is determined beforehand. Otherwise, what happens is, if they go, okay, wahan jaake dekhenge kab aana, then that doesn't happen. And then time slips on, and then the extraneous reasons come in. Like we have number of cases where actually some of them want to come back, but then the choice they get is that either you leave the family, abandon the family and come back, or you stay back. And one of the persons who had been an IIT pass out, Delhi, 80s, been known to me for many years, he was very keen coming back. But then he was here for a few months. When he went back and he called me up, he said, no, my children say that it's time for you to make a choice. And then he made a confession, which I think is an eye-opener for all of us who want to be propagated as much as possible. He said, the fault lies that my children have never visited India. Even during vacation, they went to the other European destinations. So before the extraneous factors come in and prove to be detrimental, let us plan it out very professionally. I'm going for so-and-so, for this fellowship, because this is not here. I'm going to do this enrichment to value addition, then come back. And therefore, the message should be that India has now everything to happen. I think one of the better times happening for science and research in India, and the best is also soon to come, I believe, in less than 10 years, Adil. Thank you.
Thank you so much, sir, for showing us the way forward and for leading us while motivating the new generation of scientists, administrators, and policymakers. Your commitment to nation building has been exemplary for each one of us and has been guiding us at each step of our journey to success. To finally conclude the inaugural proceedings, I would now like to invite Madam A. Dhanlakshmi, Joint Secretary, Administration, Department of Science and Technology, to propose the vote of thanks.
Good afternoon, everybody. As we draw this inspiring celebration to a close, it's my privilege and honor to deliver the vote of thanks on the occasion of the 55th Foundation Day of the Department of Science and Technology. First and foremost, I would extend our heartfelt gratitude to our Honorable Minister for gracing this event with his presence and for sharing such thoughtful insights that remind us of the transformative role science and technology play in shaping our future, our nation's future. Thank you very much, sir, for the unwavering support and guidance you have been extending to DST and its scientists. Thank you very much. I would now thank our secretary, Professor Abhay Karandikar. I'm not sure how much wealth he has amassed, but I'm very sure, I can assure, that he has earned a lot of real estate in the hearts of all the scientists and officers of DST. Thank you very much, sir, for the wonderful and insightful leadership which you exhibit daily. Thank you very much, Professor Ajay Sood, sir, Principal Scientific Advisor, for guiding and mentoring all the scientists of all the scientific departments throughout in all their endeavors. Thank you very much, sir. Thank you very much, Dr. Sarath Sharma ji, for your thoughtful and inspiring talk. You have depicted the success story in a very fantastic way and guided us on the problems or downfall of all the success which we are basking in now. Thank you very much. Thank you very much, Dr. Adil Zainul Baiji. You have, set our standards very high. Now, every day we have to dream of reaching the MIT standards, nothing below that. Beyond that, yeah. We can't now rest without reaching or going beyond that. Thank you very much for that, sir. I would thank Dr. Sanjay Bihari ji. He took us in a guided tour simultaneously within our brain and in his Lucknow Medical College also. So thank you very much for such a inspiring and thought-provoking talk which you have given. Thank you very much, CEO ANRF and all the HODs, and thank you very much, Ashutosh Sharma ji, for accepting our invitation in a short notice and coming and blessing us. I would now thank all the HODs of the Department of Science and Technologies, senior officers who have always supported us in all the endeavors we have been carrying out all along. I would thank all the heads of the autonomous institutions who have come in large number, encouraging us and being a part of our success stories. Thank you very much for all the thought-provoking and best practices you are going to share with us in the afternoon session. I would thank all the other participants who are going to take part in the deep technology program in the afternoon, the other session. I would thank all the DST members. I would thank senior officers from DBT, DSIR, CSIR, Ministry of Earth Sciences, and other science and technology institutions who have come in large number and helped us make this program a grand success. Thank you very much, one and all. And the last but not the least, I would thank my own team who have been working day and night to make this program a grand success. Thank you very much.
Thank you, ma'am. Thank you all for your participation. We will now move for the lunch, but you are requested to be seated till all dignitaries leave for the lunch. You are requested to proceed as per the designated dining areas. Please note that there are 3 dining areas on first floor and 1 on ground floor. VIP dining on first floor, where arrangements for Honorable Minister and his personal staff, Secretary Sir, AS Sir, and JS Ma'am are being made. VIP lounge on first floor, where arrangement for all HODs and directors of AIs are being made. An arrangement for all other participants are being made at foyer area on first floor as well as on ground floor. You are requested not to crowd any place and please spread out. We wish you a leisurely and happy lunch. You are also welcome to network during lunchtime. Please note that post-lunch, session will resume promptly at 2:30 p.m. There will be 2 panel sessions. One will be held at Nalanda Auditorium, where panel discussion on deep technology manufacturing ecosystem in India is scheduled. Another one at Directors Conclave, where a strategic discussion forum for directors of DST, autonomous institutes, and senior officials is scheduled. Ma'am, हम लोग भी ले लें? Thank you.